Hi, good evening, guys. I can see a question already, and to me, I do feel that this ACJC 2019 paper one is a little bit harder to tackle as compared to some of the other papers that we have done so far. Personally, I don't think this paper is a very difficult paper to do, other than the fact that we were supposed to be doing this paper within 3 hours, and I think that is a bit difficult. I wonder any one of you have actually tried this paper already, because um I hey hi whoever said hello, and and when I was trying this paper, I was just wondering, for a paper that is set of this kind of difficulty, or rather this kind of tediousness, whether it is possible for a typical student to be able to cope with the time, especially when for a lot of the question, even starting from the first page of this paper, students are already going to be committing a lot of time trying to do the substitution, trying to do the algebraic manipulation. And when I was trying, let me show you something. Okay, when I was trying to look at this paper, and then I realized that, okay, I recalled that, okay, last year, this paper was done on the 29th of August, which means that it was actually one of the earlier prelim paper that schools were holding last year. So that will also mean that for an ACJC student last year, they would have less time. He or she would have less time to prepare for this paper, and yet this paper is a little bit unforgiving, in terms of trying to really make sure a student rush through this entire paper in order for them to be able to complete this paper within the 3 hours. So anyway, my plan tonight is to try to do from question number 1 to question number 1 to question number 7. Okay, that is my aim. Yep, question number 1 to question number 7. Okay, I'm not sure whether I will be able to achieve this. But I'm seriously hoping, okay, that it is actually possible. Hang on, let me just take a look at some of the questions. Okay. Okay. Yeah, I do think that sometimes our exams can be a little bit unpredictable, but I'm still a little bit caught by surprise by this ACJC 2019 paper. I do know that ACJC has been setting harder and harder papers in the last 2 to 3 years, but looking at this paper, it really gets me thinking, like, wow, goodness, how can a typical student finish how can a typical student finish the full paper within the 3 hours? It is a huge challenge. But anyway, I'm going to start with question number 1, and we will continue all the way until hopefully we can finish all the way until question number 7 by tonight. And for the rest of this paper, we will probably continue on another day. My plan is the same as last week, so most likely we can find Friday to finish up this paper. Question number 1. This is in a way, this is a slightly simpler. This is sort of like a simpler looking system of linear equation question together with graphical transformation. So according to what that is described by this question, the graph of fx is going to undergo transformations, and it will become this graph. So I can see that it undergoes 2 transformations, A and then this minus B. So what I'm going to do is, starting from fx, yeah, but I don't know. Anyone here has actually tried the first few questions, like at least question number 1 to 5, or question number 1 to question number 7, because I tried from 1 to 8 so far, and I thought the questions were, I mean, some of the questions were really a little bit tedious. So anyway, we have fx, and it is going to undergo some transformation, and you will end up with this graph over here. So what I am going to do is to replace x, like what I've discussed on the theory outline on the Achevas TV. So to replace x, for one transformation at a time, and hopefully I can get an expression that is like this. So my plan is to first replace x by ax. Then I'm going to replace x again. So the rule is to replace this x, and I can see to get this, I'm going to replace x by x minus b. So it undergoes two transformations, which means that the point A is 2 and minus 3. It is going to undergo the first transformation, which is a scaling by a factor of 1 over a parallel to the x-axis. So all the x, the 2 here, it is going to be scaled by 1 over a. So it's going to become a point 2 over a, then minus 3. And this x coordinate is going to be scaled again. The graph that it is on, it is going to be translated by b units in the positive x direction. So if it is going to be transformed by b units in the positive x direction, then I'm going to take all the original x coordinate and I will plus b to those x coordinate. So it will become 2 over a, then plus b. Then this is minus 3. I'll do the same thing for the point b. Oh, and this point here is the point a prime. Okay, and according to the question, a prime is 7 and minus 3. A very unique question by itself. Okay, and it is actually, it will end up as a system of linear equation question. So for b, I started off with the point minus 3 and 1. Okay, I started off with the point minus 3 and 1, and it is going to be replaced, it is going to be, x is going to be replaced by ax. So it is going to be scaled by 1 over a parallel to the x-axis. So minus 3 over a, then 1. And then it is going to become b prime, where all the x coordinate is going to undergo a transformation of b units in the positive x direction. So it will be minus 3 over a plus b, then 1. So according to the question, b prime is given to us as minus 1, 1. So now I can do a comparison between the two coordinates. From a prime, we know that 2 over a plus b, this is going to be equal to 7. And as for b prime, we know minus 3 over a plus b, this is equal to minus 1. We are supposed to solve for a and b, and in order for us to be doing this as a system of linear equation question, what we can try to do is to just change our perspective in looking at these two equations by rewriting this or looking at this from the perspective of, instead of 1 over a, instead of 2 over a, I'll see it as 2 multiplied by a variable, and that variable happened to be 1 over a. Then plus b, this is equal to 7. I will call this equation number 1. Then my equation number 2 will be minus 3 times the variable is the entire 1 over a. Then plus b, this is equal to minus 1. This is going to be my equation number 2. Then we will be able to make use of our graphing calculator to try to solve this pair of equations as a pair of linear equations. Okay, and this is what I have pressed into my calculator. Let me quickly show you guys. So I have pressed this into my calculator, where the coefficient is according to the coefficient that I've written down here. So it's 217. So that is what I've pressed. The same for the other one. And if I were to just get the answer from my calculator, the answer from my calculator gave me this, which means that 1 over a is going to be equal to 8 over 5, and b is going to be equal to 19 over 5. Which means that a over here is equal to 5 over 8. Okay, provided that we are able to see this from another perspective, then it will be possible for us to see this as a system of linear equation question, okay, because we want to try to see 1 over a as a variable by itself. For Joe, yes, you can also consider this transformation, replacing x by x minus a, and replace x by ax. Yes, yep, I think this is possible also. If you were to do this, yep, this is possible. Okay, I think this is a good idea too. Plus b as in like hang on, let me remove this. Plus b as in like replacing x by x minus b, or do you mean that you want to replace x by x plus b? Because according to the question here, right? According to the question here, we are supposed to be replacing, we are supposed to end up with this x, a times x minus b. So replacing x by x minus b is somewhat a good idea. And for what Joe has mentioned just now, right? He or she was suggesting that fx, we will replace it by x minus ab first, because we can see this as also ax minus ab, right? So we are also seeing as this. So then we will replace x again by ax. So it will be ax minus ab. So there will be two transformations. The first is to add all the numbers. For example, if I have a, which is 2 minus 3. Hang on, let me write properly. Which is 2 minus 3. Then going through this transformation, since it is going to be a translation of AB in the positive x direction, so we will take 2, then we will plus AB. Then it will be this, then minus 3. Then replacing x by ax, we will divide this entire thing by a. So the next point is, sorry, this shouldn't be a point a anymore. So the next point should be 2 plus ab over a, then minus 3. If we are going through this particular transformation, okay? So then we will get this, which in the end, it is exactly the same as this, right? It is 2ab over a is equal to 7. Can I show you something that is a bit unusual? For a prime, why is the x coordinate 2 over a plus b? Why is the x coordinate 2 over a plus b? Okay, I find this question a little bit difficult to answer. Because x is going to undergo this, for example here, right? This 2 is going to undergo the first transformation. And the graph from this to this, it is going to be a scaling by a factor of 1 over a, right? Replacing x by ax is going to be a scaling by a factor of 1 over a. So whatever original x coordinate, it is going to be divided by a times. So if the original x coordinate is 2, then it will become 2 over a. Then from this graph to this graph, it is replacing x by x minus b. So replacing x by x minus b, that means for whatever that is on the graph, it is going to be translated by b units in the positive x direction. So all the x coordinate will become bigger by b. It will be added. B will be added to all the x coordinate, because all the entire graph from here to here, it is going to be translated by b units. So if I have a 2 over a, then it will become a 2 over a plus b. So because it is going to be shifted by b units in the positive x direction. Okay, I'm not sure whether I get I don't know whether you are the same person who asked this, but I'm a little bit confused by this minus b thing also. As in, like, I don't really get why it should be a minus b when it is supposed to be a plus b. Okay, because we are shifting. Can I just give you a very quick example? before I show you something which I feel that it is not the most usual way to do this question, but it is actually possible. Some of you, if you can get it, maybe you will like it. Like for example, if I have a f x, and there's this point A, and for example, let's say this point A is 2 and minus 3. And if it undergoes a transformation where we are going to replace all the x by x minus 5. So replacing x by x minus 5, that means the graph is going to be translated by 5 units in the positive x direction, which means that this point 2 will become a point 10 and minus 3, correct? So how do we get 10? Because we took 2 plus 5. So minus 5 here tells us that we are going to be translating the graph by 5 units in the positive x direction. So 2 will go to 2 plus 5. Oh, sorry, 2 plus 5. This is going to be equal to 7. Okay, so it is going to be a 7, which is what I did here. So if it is minus b, tells me that it is going to be moving by b units in the positive x direction, then it will become whatever x coordinate plus b. Okay. Can I show you guys something? Not the most common way to do this question, but it is actually very, very logical, how to get this equation and this equation. For example, right, we know that this A and B lies on this graph, right? A and B lies on this graph, which means that, for example, point A, since point A lies on the graph, it must satisfy this graph, which means that, let me just write it in green color, okay? So which means that F2 is going to give me a minus 3, correct? F2 should give me minus 3. Okay, right? If I were to sub this into here, F2 is equal to minus 3. And this point A prime is going to be lying on this, all right? This point A prime is going to be lying on this, which means that if I were to look at this, if I were to sub 7 in, that means I have a F of A of 7 minus B, and the output should be equal to minus 3, correct? Which means that if you think about it, right, since the output remain the same as minus 3, that means this is going to be the same as F of A of 7 minus B, right? They are the same. And since they belong to the same function, this tells me that 2 is going to be A times 7 minus B. And it will be like 2 over A is 2 over A is equal to 7 minus B. So 2 over A plus B is equal to 7. Without even having to discuss about transformation, I have already gotten my first equation. Similarly for the second point B, which lies on this graph, which means that F of minus 3, which is 1, it should be the same as when I substitute minus 1 into here, and I will get 1. So I have a F of A times of minus 1 minus B, which should give me a 1 also, since they share the same output. And since they share the same function F, that means minus 3 is going to be equal to A times of minus 1 minus B. That means minus 3 over A is going to be equal to, okay, and then B, I'm going to shift it over. So this plus B, this is plus B, this is equal to, whoops. So this plus B, this is equal to minus 1. This actually gets me my second equation. Okay, a very, very simple, like comparison and then points on a graph kind of question. And I actually skipped transformation entirely. I did it purely by using algebra. Okay, it is also possible because they happen to share the same output. Okay, actually, for some of you who have some time to go and think about it, this algebraic process that you are seeing here actually describes the transformation without us having to undergo the actual physical transformation of the graph, because the one that our schools taught us usually require us to do the transformation. Okay, anyway, this is just something that I thought of that maybe I can share with you guys. If you if you like it, maybe you can just give it a try also. Okay. Let me continue with question number 2. I'm going to try to see whether if I rush a little bit more, because I know to do question number 1 to question number 7, it is actually a little bit tedious. I mean, because of the nature of this paper. Okay, so I'm going to try to see whether if I can just rush that little bit more, whether you guys can still follow me, and I want to see whether I can finish it within 1.5 hours. You know, at least question number 1 to question number 7. You know, Claire, I can see you said something, and I think you are trying to talk about, you know, the suggestion that I've made, because what you say seems to be very, very similar. So if you are trying to say this relating to the green colored part that I wrote there just now, right? I think you probably have the same idea as what I've just talked about. Okay, thanks Alvin for counting down 1 hour 10 minutes. I'm going to use differentiation to find the area of the largest rectangle with sides parallel to the coordinate axis lying above the x-axis and below the curve with the equation y is equal to 44 plus 4x minus x squared. So I know this graph that I'm looking at here is a parabola. It is the set face kind of parabola because the coefficient of x squared is negative. So we are probably looking at a parabola that is something that is like this, and then there's this rectangle that is inside that is within the parabola, with the sides parallel to the x-axis and the y-axis. And since it is the biggest possible, so the sides must be touching the curve. And what else? Okay, I guess that's it. That is it from the question. Let me redraw this properly. Okay, so with the idea that we have here, if you can just do a quick sketch onto your GC, you'll be working on a parabola. And for this parabola, the maximum possible point here is, I've already found it to be 2 and 48, which means that the y-axis is going to be here. The y-axis, the x-axis. When I was trying this out myself, there are actually a few different ways to do this. But let me just show you what I think is the fastest possible way to deal with this question, okay? So we have that rectangle according to what the question has suggested to us, which is a rectangle that is like this within the circle, and it is the largest possible rectangle. So the corners must be touching the rectangle. And because this is a parabola, and if the rectangle is this way, this also implies that the rectangle should be symmetrical about the center, about the center line of the parabola also. So this is equal to, this is at 2. If I were to call this point here with a coordinate of xy, that means the x coordinate here is, the length here is x, and the length here is y. And since this curve here is y is equal to 44 plus 4x minus x squared, that means I know this y, if I were to replace it by x, it will also be 44 plus 4x minus x squared. So we now have the height of the rectangle. What we don't have is the width. But I know that since this is 2, and I know since here to here is x, I know here to here it will be x minus 2. This tells us that for the area of the rectangle, it is going to be base times height. This base is twice of this distance, x minus 2. So it is going to be 2 times of x minus 2 multiplied by y, which I can also rewrite. So let me rewrite this y as 44 plus 4x minus x squared. Okay, and we are going to try to make use of differentiation. So we will find dA dx, and we will let dA dx be equal to 0, by using the idea of stationary point. So we will do another check to verify that this stationary point is also a maximum point, and that should help us to find the area of the largest possible rectangle which is something that is similar to what I've drawn here. So for me to differentiate this, I think one algebraic step that I should do, okay, is I should probably try to expand this. So it will be 44x plus this times this 44x plus 4x squared, then minus x to the power of 3 minus 88 minus 8x plus 2x squared. So simplifying this, we have a minus x to the power of 3 plus 6x squared plus 36x minus 88. And this, I'm going to just do a differentiation to it so that I can get an expression for dA dx, and I'll let it be equal to 0. So this is 2 times of minus 3x squared plus 12x plus 36. Okay, let me just factorize out minus 3, okay? So I'll have a minus 6 of x squared minus 4x. Then factorizing out minus 3, this is going to be equal to minus 12. And I am going to let dA dx be equal to 0. Letting dA dx be equal to 0, that means minus 6 of x squared minus 4x minus 12, this is equal to 0. We can factorize this. This will be x plus 2 and x minus 6. This is equal to 0. So x should be minus 2 or x should be equal to 6. I'm going to take x to be equal to 6 because I'm more interested in this x value instead of this x value. Okay, and I know this x value is going to be a number that is bigger than 2. Okay, so I'm going to go for this x value so that I can be looking at the area as a positive number, which is going to be the length, the base times height. So I'm going to take x is to be equal to 6, and I want to try to verify that, or even though, I want to try to verify that on top of x is equal to 6 giving me a stationary point for A, it is also giving me a maximum point. So I'm going to make use of the second derivative. So let's try to find d square A dx squared. So we'll differentiate this one more time, minus 6 of 2x minus 4. And I'm going to substitute 6 in. So d square A dx squared. If I were to let x be equal to 6, this will be minus 6, 2 times of 6 minus 4. This gives us a minus 48. And this is less than 0. Therefore, I know A is a maximum. And the maximum possible, the largest, since the question asked me for the largest. So the largest possible A is going to be equal to, when x is equal to 6. So it's 2 times of minus 6 to the power of 3 plus 6 times 6 squared plus 36 times 6 minus 88. This is equal to 256. Okay. And the reason why I am using x is equal to 6 instead of x is equal to minus 2, the reason why I'm using this is because I am from the very beginning, right? I've chosen x to be this. So this length here is a x minus 2, which is supposed to be a positive number. Y is also supposed to be a positive number according to my diagram. Then it is going to give me a positive A. So I've already chosen an x that is bigger than 2 to get the half of the length. If I were to use minus 2, if I were to use x is equal to minus 2, that means I'm going to be using something that is here. an x value that is here, which means that I shouldn't have used an x minus 2. If I'm prepared to use this x, I should have written this as this length here. It should be a 2 minus x. Okay, then minus 2 will be 2 minus minus 2. It will give me 4. Okay, so the reason why I've chosen the 6 is because I want to make sure that the area that I am working on is always going to be a positive number. This is question number 2. By the way, there are a few different ways of doing this. I mean, not a few different ways. I've tried another way, which is to work on A with respect to Y instead of working on it with respect to X. It will work too, so you guys can give it a try. The solution is going to be a little bit longer, but it's not too bad. I think it is still possible to get it is still possible to work through within a short enough time. Okay, I'm going to continue to look at question number 3. Yeah, I would suggest that for x is equal to minus 2, right, we will reject. So in the solution, I will probably say that I'm rejecting this based on the diagram that we have drawn. Because if you have used minus 2, I didn't go and try it myself, but if you have used minus 2 and resubstitute it back into a, you will get a negative value, which means that if you were to do a second derivative, most likely you are going to get a d squared a dx squared as a positive number. So you're going to find the minimum possible a instead of the maximum possible a. So even if you didn't reject negative 2, in the end, when you try to find maximum minimum via the second derivative test, you will end up with choosing 6 as the maximum, because the other one is going to give you a maximum number. The other one is going to give you a minimum. I find 3 a very unassuming question, but it turns out to be very tedious, like way more tedious than I've expected. And there's this small little trap, I will say, and it is only when you get a bit more meticulous, then you'll probably be able to spot it. So first of all, we are supposed to try to solve for this equation, which seems okay. It is just an equation with a modulus, so it's very similar to what you have done in your secondary school. Where it is the second part that I think is going to get a little bit more tedious than expected, and it will actually affect the answer that is in the first part. So anyway, let me show you what I mean. Okay, so I'm going to try to solve this. So we have a modulus of x squared plus 3x, this divided by x minus 1. So this is equal to 2x plus 3. So to remove the modulus, if I were to remove the modulus, we will have two cases. X minus 1 is equal to 2x plus 3, or another case will be x squared plus 3x over x minus 1 is minus of 2x plus 3. So for this first equation, I am going to try to solve for x. So I have this is equal to 2x plus 3 multiplied by x minus 1. Let me write it down here so that I can have some space for this later on. So this will be x squared plus 3x. Expanding this, we will have 2x squared. 2x squared minus 2x squared minus 2x squared plus x. So 2x squared plus x minus 3. And I will be ending up with x squared minus 2x minus 3. This is equal to 0. So x plus 1, x minus 3, this is equal to 0. This tells me that x must be minus 1 or x must be equal to 3. I'll do likewise for this. So I will have x squared plus 3x. This is minus 2x plus 3 and x minus 1. So it will be x squared plus 3x. Expanding this, I will be getting this anyway. So it will be the same as this. It is just that it is negative of this. So this will be minus 2x squared minus x plus 3. So I will end up with 3x squared plus 4x minus 3. This is equal to 0. And sadly, this cannot be factorized by this what is this called? This is a square method. or what do we call it in secondary school, where we cannot, factorize this in this way. So I'm going to use the quadratic formula, okay? Because the question asks for the numbers exactly. So quadratic formula, minus b plus or minus square root of b squared minus 4ac. This divided by 2a. So this is equal to minus 4 plus or minus, I'm going to factorize out the 4. So I have a square root of 4. Square root of this is going to be equal to 13. And divided by 2 times 3. So I'm going to be ending up with minus 2 plus or minus square root of 13 over 3. Okay, so we have these these 4 numbers. I am going to write down these 4 numbers here. Okay, so solve. So I've solved. I've gotten this. There's a twist to this. Okay, in case some of you have done this and you realize the twist, give me a short while. Okay, so so as of now, most likely, I was just imagining. Okay, most likely, if I were to be doing this in exam, I will be ending with x is equal to minus 1, or x is equal to 3 for the first part, or x is equal to minus 2 minus square root of 13 divided by 3, or x is equal to minus 2 plus square root of 13 divided by 3. Okay, so we will end up with this. And let's try to sketch the graph first, okay, before we come and revisit these 4 answers again, because the graph will show otherwise. So I'm supposed to, in the next part, right, we are supposed to sketch the graph to solve the inequality. So we will be sketching the graph of the left hand side. So we'll be sketching y is equal to this, and we'll be sketching y to be equal to this. Okay, so we'll be sketching these 2 graphs. I have already pressed this into my calculator. Let me show you what I've gotten. Okay, so for this question, I have gotten this on my calculator. If I were to be drawing the 2 graphs together. Oops. Okay. Is it showing? Oh no, where's my graph? Okay, let me try it again. Okay, so my graph is here. Yep. Oh no, my graph disappears again. Oh, okay. Goodness, it is like disappearing and appearing again. What is happening? I am so scared that my computer will just suddenly hang, because it hanged the other day when when I was trying to do something that is similar to this also. Okay, anyway, I've gotten a graph that is like this, and if you were to look at this graph, right, this is the graph where the blue colored graph represents the left hand side, and the red colored graph represent what we have on the right hand side. And when they intersect at this point here, and this point here. They intersect at 3 points, which is different from what we have calculated from the equation. Because from the equation, we get 4 answers, which means that there should be 4 intersections. But my graph is not going to lie to me. My graph clearly shows that there are supposed to be only 3 intersections, which means that of these 4, one of them is going to be incorrect. We need to do a test. It is actually very easy to test. We just need to substitute the numbers back into the original equation, and we make sure that the left hand side is equal to the right hand side. That's all. So we just do a quick substitution of all the 4 values, and you will probably realize that this number here is incorrect. This number here is supposed to be rejected. It's either you do a substitution, which is brainless and fast. In the exam, I would suggest that you do that. Or you can try to do an analysis. This analysis is based on the fact that you know modulus is going to be positive, correct? So if modulus is going to be positive, that means 2x plus 3 is going to be positive. It is going to be bigger or equal to 0 all the time. Because on the left hand side, it is going to be bigger or equal to 0. On the left hand side, it just simply cannot be negative, which means that from my graph, it indicates to me that one of these values must be rejected. And we know something that is like this. Let me write it in black color. So we know that since 2x plus 3, which is equal to modulus of a number, since this must be bigger or equal to 0, which implies that for whatever value of x that I've gotten, x must be bigger or equal to minus 3 over 2. Minus 3 over 2 is minus 1.5. And if you were to press these few numbers into your calculator, I've already done that. I mean, this is definitely bigger than minus 3.5, so it is fine. This is bigger than minus 3.5, it is fine. This number here is minus 1.8685, which is not satisfactory because we want numbers that are more than minus 3.5. This number here is a positive number, 0.53518. That is why of all of the four numbers here, this number is going to be rejected because x is supposed to be a number that is bigger or equal to minus 3 over 2. Okay, so this is one minor detail which I suspect that in 2019 probably quite a few students would have missed this. But because in the next part of the question they have already asked you to draw a graph, so let's also consider whether we can be a little bit more sensitive to small changes and details that is in a question that probably can help us to find find ways to do this part more correctly. And the graph is surprisingly difficult to produce for a 2 marks question. I do hope that ACJC could have given more marks to a graph that is as difficult as this to sketch, because I need to first sketch this graph, and this graph is the reflection. It is modulus of a graph of y is equal to x squared plus 3x over x minus 1. This is graph of a rational expression, which means that this graph will have oblique asymptote. If you do a long division to this, I've done that, you will get this as x plus 4 over x minus 1. So it has an asymptote of y is equal to x plus 4, and it has a vertical asymptote of x is equal to 1. Okay? And rather than drawing it based on this blue colored graph, which I personally found a little bit more difficult to sketch, where I'm going to try to sketch it based on the original graph of this, then I'll do the reflection myself. Let me show you what I've gotten, okay? So if I were to draw the original graph without the modulus, I have something that is like this. Yep, I guess someone has already answered you. 2x plus 3 is more than or equal to 0 because of this. Because 2x plus 3, because 2x plus 3 here is equal to a modulus number. So for a modulus number, we know the output is going to be always bigger or equal to 0. That is why 2x plus 3 has to be a number that is bigger or equal to 0. Okay, which is what I've written down here. Okay, anyway, I find this blue colored graph harder to draw because of us trying to include the asymptotes and stuff. That's why my suggestion is to draw this graph first, then we will do a manual reflection. And even so, I find myself taking quite a fair bit of time drawing this graph. So let me see how fast, how accurate I can draw this graph. Okay, I think the problem is really to draw this graph within the time that is given. And furthermore, ACJC is giving only 2 marks. That is why I feel that it is not an easy question to do within the 3 hours. But if time is if you are not rushing for time, it is still probably okay. it's not such a difficult question. So first I am going to sketch in the asymptotes like what I suggested to you guys since the very beginning when we started this live stream. We should try to draw asymptotes first, then after that we sketch in the rest. So we have a y-axis, we have an x-axis. We have a vertical asymptote x is equal to 1. So let me sketch in the vertical asymptote x is equal to 1. And I know once I've drawn this graph, everything is going to be, it is going to be easier for me to write down the solution to this inequality already. So we have this. This is the line x is equal to 1. Okay, it is from the denominator here. It is the value of x that caused this entire expression here to be undefined. We have an oblique asymptote. Let me sketch in this oblique asymptote. So it has a gradient of 1. And it touches the y-axis at 0, 4. So we have this. And this is the line y is equal to x plus 4. So we have a graph that is like this, which I am going to try sketch it this way. And for this portion of the graph, it passes through 0, obviously, because if I were to substitute 0 into here, y is equal to 0. So for this part of the graph, it is going to be reflected. So this part of the graph, it will be reflected. So we have this. Okay, it passes through the origin. So we have this. And we'll have this little hump here. So maybe it is something that is like this. Okay, and as for this part of the graph, it is going to be reflected. And because it is reflected, we need the reflected asymptote also. And the reflected asymptote, let me sketch it as something that is like this. So it's supposed to pass through this point all the way. And this reflected asymptote, because it is reflection about the x-axis, so I'm going to replace x by minus x. So the equation is y is equal to minus x plus 4. And my graph, this part of the graph, will look like this. So it should tend towards the asymptote. Okay, not exactly the nicest here, but anyway, it is supposed to be a nice smooth curve. Okay, all the way. And I guess this number here is minus 3. 0, because if I were to let this be equal to 0, x is either equal to 0 or x is equal to minus 3. And we are supposed to also sketch, I'm going to use red color just like this, okay? We are supposed to sketch the graph of y is equal to 2x plus 3. And I did a few tests, to just make sure that I'm drawing this correctly. And I actually realized that this y is equal to 2x plus 3 is going to pass through the minimum point. And it is going to pass through, let me see, it is going to pass through this point. Which I wasn't really expecting, because after I've drawn this graph, I went to draw the graph of y is equal to x plus 4 also, just to see how I should be drawing the graph properly for you guys. Then I realized that, hey, it seems like something is happening here. So when I substitute 1 into this, I get a 5. When I substitute 1 into this, I've also gotten a 5. That makes me realize that, hey, it passes through this, it passes through this. So it passes through these 2 points. And this point here, happen to be in a minimum point with a coordinate of 3 and 9. Okay, so you will continue. And it actually passes through the maximum possible point here also. So this is going to go down, passing through the maximum possible point, and then continue as a graph. Okay, I shouldn't have drawn this here, but anyway, here the maximum possible point, which happened to be also the place where they intersect, is at minus 1, 1. And so this is the graph of y is equal to 2x plus 3. And in case some of you were wondering, are these details really necessary? I feel that they are necessary if you are actually able to have the time to sketch, but for 2 marks question, I'm not very sure. But when I was trying to look at some of the scripts of my students last year, I do realize that for certain schools, if you are not meticulous enough in trying to indicate the relative positions of points, you are actually, you will actually be losing marks. So I mean, I'm not sure, so I'm going to just put in as much information as possible as I think I possibly can do. Okay, so we are trying to look for the y coordinates. We are trying to look for the x value such that this graph is going to be below this graph in terms of the y coordinate. So I will be looking at their intersection, which is going to be this point, and the x coordinate is -1, which is synchronized to this. And we are looking at this point here. When this point here was synchronized to this 0.5 something, which is less than 1. So the x coordinate at this point is -2 plus square root of 13 divided by 3. And finally, it is going to synchronize to this point. This point is when x is equal to 3. So my final answer is for the regions of the graph where this graph is below this graph. So I will say that it is going to be from here. This is going to be the x coordinate, and then from here. Therefore, based on the graph, my answer will be x to be strictly bigger than -1 and strictly less than -2 plus square root of 13 over 3. Or another region is going to be this region. So that will be when x is strictly bigger than 3. For the line y is equal to -x plus 4. It is when we try to take this portion of the graph. We took this portion of the graph and we reflect it about the x-axis, which gives us then this portion. And for this portion of the graph, it is supposed to be tending towards the oblique asymptote y is equal to x plus 4. So in order for us to have the corresponding oblique asymptote for this part of the reflected graph to be tending towards this y is equal to -x plus 4 is a reflection of this graph about the x-axis. Okay. Oh yeah, it should be -x minus 4. This is my mistake. -1 mark. You're right, Alvin. So it is my mistake. It should be -x minus 4. Where it is putting negative to the entire expression, not just replace x by -x. This is my mistake. Replace x by -x is a reflection about the y-axis. So we should take this entire thing, then multiply by -1. So it should be -x minus 4. Where is my mistake? So let me do my correction here. Okay, so this graph here should be y is equal to -x minus 4. So this is incorrect. But this graph is really having a lot of details, which is very unexpected for a 2 marks graph. Next, let's take a look at question number 4. Question number 4 is a rate of change question. And for those of you who are attending my tuition class who are also here, we have been doing a lot of rate of change questions for the last 3 weeks. And I am hoping that by now, when you see this particular kind of rate of change question, you will find it terribly easy. Because we have definitely been doing rate of change questions that are way more difficult than this question number 4. Hang on, let me see where is my question number 4. Something weird that I realized is that whenever I do my live stream, like here, right? Then whenever I'm at my second or third question, then my screen is going to be like temporary, like hanging for a little while. That is very weird. And then because I know what is the problem. The problem is with my laptop. And I'm wondering whether any of you here are like gamers and you are using a laptop with very high specifications. When you are gaming and live streaming, does your computer hang? When you are going for when you are rendering a lot of graphics at when you are gaming and live streaming at the same time? Okay, anyway, next question number 4. Question number 4, I personally find it confusing in terms of the way the question is being described. So we have this kite that is 50 meters above ground, and this kite is blown away from this person at a speed of 5 meters per second, and the string is always going to be taut, and the length that the string is let out is, when the length of the string that is let out is 100 meters, we are supposed to find the rate of change of the angle that is between the string and the ground. So we are looking at a scenario that is something like this. Let me try to do a quick sketch of it. So let's say this is the ground. Okay, so for example, if someone is standing here and the kite is, let's say, here. So according to the question, the string is always taut. So we are looking at something that is like this. And for this kite, it is moving parallel to the ground at a speed of 5 meters per second. And we are supposed to try to find the rate of change of the angle that is between this string and the ground. And we are looking at this angle. I'm going to call this angle theta. Okay, when the string is 100. Okay, but please remember, the string is not always going to be equal to 100. The person is letting strings out, so that the length of the string is changing, and we are supposed to find the rate of change of theta when the length of the string happen to be 100. So I'm going to call this a variable, let's say y. And if you think about it, it is actually pretty relevant for us to form a right-angled triangle that is like this, because according to the question, the kite is 50 meters above ground. So this length here is 50. And if I were to draw this as a right-angled triangle, we can call this x. And you know what is the use of this x? Because this point here, which is the kite, is moving at 5 meters per second. This tells me that every 1 second, x is going to be increasing by 5 meters. So this piece of information here, with x that I've indicated on the geometry here, tells me that, I can make use of it by indicating it as dx dt is equal to 5. So for part 1 of the question, we are supposed to find d theta dt. We are supposed to find d theta dt. So to find d theta dt, we need an equation in terms of theta. And I'm going to try to relate it to either x or y. I think I'm going to go for x. Later I can explain to you why also. If I were to relate this to x, one other theta that I can see, which is the same as this theta, is by making use of alternate angle. This here is theta. So if this here is theta, using Picasso, we know tangent of theta, this is opposite over the adjacent. So we have this. And if I were to differentiate this equation with respect to t, applying implicit differentiation, this is going to be secant square theta d theta dt. And differentiating this with respect to t, we have a minus 50 over x square of dx dt. And we are supposed to find the rate of change of theta when y is equal to 100. Okay, when y is equal to 100. So if you were to look at this rate of change equation that we have formulated, that means in order for us to find d theta dt, we just need to make sure that we find x, we find dx dt, and we find theta then we will be able to find d theta dt. To find dx dt, we have already deduced that. So I know that from here, dx dt, this is equal to 5. It is pretty simple for us to find x also by making use of the Pythagoras theorem. We know x is going to be equal to square root of y square minus 50 square. And that will be square root of y square. Y happen to be 100 for the rate of change of theta that we are trying to find. So this is going to be 100 square minus 50 square. This gives us a square root of 7500. So this is x, which means that so far we have already settled this. And the next thing that we need to do is to find theta. And to find theta, we definitely can try to substitute x back into here. Then theta will be tangent inverse of this. Or if you can actually make use of trigonometric identity, why not we try, instead of finding just theta, why not we find secant square theta? So for secant square theta, it is 1 plus tangent square theta. So this is 1 plus tangent square theta. And tangent theta is 50 over x. X is equal to this. So we are talking about 50 over x, which is square root of 7500 square. So the square, secant square theta, this is going to be equal to 4 over 3. So now we have also found this, which means that we can find d theta dt by substituting all these three quantities into this equation. We will have a 4 over 3 d theta dt. This is minus 50 over x square, and that will be 7500. Square of it, square is 7500, multiplied by 5. This tells me d theta dt, and this is equal to minus 1 over 40. In a way, it is expected to be a negative number because for the situation that the question has described to us, we can see that as time increases, theta is going to be reduced. So we are expecting a rate of decrease for theta. X square, secant square. We can use x square, secant square theta, y square. X square, okay. Yes, since we have since we have x, since we have y, so we can also make use of Tokaso to find cosine theta, which will also give us secant theta, then secant square theta. Next, we have part 2, which is actually pretty simple. I'm not sure why they are giving 4 marks. So I find it a little bit inconsistent. Okay, when I was doing this ACJC paper, like, wow, goodness, isn't this like very, very easy? Because we want to find the rate that the string of the kite is being let out when y is equal to 100. So basically what this question is asking for is a dy dt. Wait, the question is asking for a dy dt. So we need an equation in terms of y, and I guess the obvious one to make use of is the Pythagoras theorem. So y square is going to be equal to x square plus 50 square. And if I were to differentiate this equation with respect to t, we have a 2y. Then dy dt, this is equal to 2x of dx dt, which means that we have a y dy dt. This is equal to x of dx dt. And we are supposed to find dy dt when y is equal to 100. So in order for us to find this, we know that we just need to find this, and this. When we already know what is dx dt, so I'm going to just code this, okay? So dx dt is not going to change dx dt is still going to be equal to 5. And from the previous part, when y is equal to 100, we have already found x. X is square root of 7500. So we have found this, and we even know y, which is 100. And now we can just substitute this into this equation here, which gives us 100. Then dy dt, this is going to be equal to x, which is square root of 7500. Dx dt, this is equal to 5. So dy dt, this is going to be equal to square root of 7500 over 20. Or if you were to simplify it, I've sort of like simplified a little bit. It is going to be 5 square root of 3 divided by 2. And for this, we are getting 4 marks. I'll probably just try to, if I know that question number 4 is so easy, I'll probably sort of like skip question number 3b. Then I'll do question number 4 part 2 first. Okay, let me do question number 5. Let me see what is question number 5. Oh, question number 5 is a Maclaurin's question. So for question number 5, question number 5, we are given this, we are supposed to show this, and then by further differentiation, we are supposed to find the Maclaurins of, we are supposed to find the first 3 non-zero terms of the Maclaurin series for this. So let me just very quickly quote what we have in the MF26 over here. So MF26 gives us, our formula sheet gives us fx to be equal to f0 plus x times of f prime 0, then x squared over 2 factorial of f prime prime 0, and so on. Okay, so I'm just quoting the first 3 terms, and hopefully there are 3 non-zero terms. Then I just need to differentiate until I get a d square y dx square. But first, let us try to show this. And I think in order for me to show this, show that differentiation of this can get me this, I think what I'm going to do is to do a little bit of manipulations to the equation. I have a 1 minus e to the power of 3x, which I'm going to rewrite it as tangent inverse of y. This is 1 minus e to the power of 3x. So when I differentiate the left hand side, implicit differentiation, this is going to be 1 over 1 plus y squared, then multiply by dy dx. This is equal to minus 3e to the power of 3x, which means that dy dx, this is going to be equal to minus 3 e to the power of 3x multiplied by 1 plus y squared. And I guess this synchronized to this. Therefore, I know that k that the question is asking for is equal to minus 3. We definitely need to do differentiation one more time, because so far from here, by letting x be equal to 0, we can get f0. Then we need at least f prime prime 0. This is going to give me a f prime 0. So let's differentiate it one more time before we substitute all the x, before we replace all the x by 0. Okay. I am planning to do half of the paper. So my aim is to finish within the next, by 9:30, which I don't think I will be able to do it, but hopefully by 9:40 I can finish this question and another 2 more questions. My aim is to do until question number 7. So let me differentiate this one more time. D square y dx square. And for the rest of the paper, I will probably continue on Friday. So differentiating this again, I'm going to make use of product rule. And this is going to be 2y of dy dx. Then plus differentiating this, maybe let me just write it directly. It will be minus 3 times 3, so minus 9. Then e to the power of 3x of 1 plus y squared. So now I have a minus 6 e to the power of 3x of y dy dx. Then this, I can either leave it as it is, But I know that if in case I need to do a d cube y dx cube, well, then it will be pretty troublesome for me to differentiate this because it is going to become sort of like tedious. So I'm going to try to replace this with what I've already gotten here. Okay, so this says that minus 3e to the power of blah 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 is dy dx, which I see part of it here. So if I were to just factorize out 3, then we will have a minus 3e to the power of 3x and 1 plus y squared. So d square y dx square will be minus 6e to the power of 3xy dy dx plus 3 times of this, which I am going to replace it by dy dx. So just in case we need a d cube y dx cube, okay, it is at least a little bit more manageable here. So now I'm going to do the substitution because I've already gotten 3 parts of the coefficient, and as long as all the 3 of them are non-zero, then we would have gotten the first 3 non-zero terms. So let us try when x is equal to 0. When x is equal to 0, when I substitute into here, we have y to be equal to tangent of 1 minus e to the power of 0 is 1. So tangent 0, this is equal to 0. This is giving me an f prime 0. So this is done, and this is not good. Because this happened to be equal to 0, which means that I cannot be using this term. So very likely it is almost definite that we need to differentiate it one more time because we need to write down the first 3 non-zero terms. So this will be cube over 3 factorial. We are expecting this already now. So f prime prime 0, and hopefully we don't have to go for the 4th one. Let's continue, okay, and hopefully dy dx is not going to be equal to 0. So for dy dx here, it is going to be minus 3. E to the power of 0 is 1. Then 1 plus y is equal to 0. So 0 square is going to be 0. This is minus 3. Okay, we have our first non-zero term, which is going to be for the x, the coefficient of x. So this is this is f0. So this is f0, and we are looking at this. This is f prime 0. Okay, which is good because it is not a 0. And let me check d square y dx square. So for d square y dx square, it will be minus 6. Oh, y is equal to 0. So this will be 0. Then plus 3 times of minus 3. Nice. This is minus 9. So this is also non-zero. So we have now 2 non-zero terms. We need the 3rd one. So let's differentiate this one more time. Let me erase this. Okay, differentiating this again gives me a d cube y dx cube. And I'm going to differentiate this, which is minus 6 e to the power of 3x. Then I'm going to differentiate this, which I'm going to use the product rule. So y d square y dx square plus differentiating y is dy dx times dy dx. Then plus now differentiating this, which should be a minus 6 times 3, it will be minus 18. So minus 18 e to the power of 3x and y dy dx plus 3 times of differentiating this, which I am glad I've taken care of it here. So now when I differentiate this, it is just simply going to be d square y dx square. And let's do a check. And let's really pray that we will be getting a non-zero term for this, or else we have to do a d4y dx4. So when x is equal to 0, d cube y dx cube. This is going to be equal to minus 6 times e to the power of 0 is 1. Y is 0, so nothing. This is going to be dy dx times dy dx, so minus 3 times minus 3, this is going to be plus 9. Then minus 18, this is equal to 0, so this will disappear. plus 3 times of d square y dx squared, which is minus 9. And this, if you were to press into your calculator, this is minus 81. And this gives us a f prime 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 0. So we have gotten the coefficient of the first 3 terms. And this f prime 0, we found, this is going to be equal to 0. This we found out to be equal to minus 3. And this is equal to minus 9. And here this is equal to minus 81. So now we can quote y, which is this tangent of 1 minus e to the power of 3x. Where y is equal to this, which is going to be equal to f prime 0, which is 0, plus x times of, f0, which is 0, plus x times of f prime 0, which is minus 3, then plus x squared over 2 factorial of f prime prime 0, which we found it to be minus 9, plus x to the power of 3 divided by 3 factorial of f prime 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 0, which is minus 81, and so on. So this is equal to minus 3x minus 9 over 2x squared minus 27 over 2x to the power of 3, and all the way until infinity. And the next part of the question requires us to take the first 2 terms of the Maclaurin series of this. So we are looking at these 2 terms. Taking the first 2 terms of the Maclaurin series of this, we are going to try to match to the first 2 non-zero terms for the Maclaurin series of this to solve for a and b. So for the second part, let's take a look at this x over a plus bx. So what we are going to try to do is to re-express this entire expression over here to become a polynomial. Okay, so we are going to try to re-express this as a polynomial. And to do that, we are going to bring this up to the numerator and looking at it as if it is a plus bx to the power of minus 1. And the reason why we are doing this is because we have another formula that is in our MF26, the formula sheet that we have for our A-level H2 math, which allows us to re-express this as a polynomial. Okay, that is like the binomial expansion portion that is in our MF26. So to make use of that, I'm going to first factorize out a, so a to the power of minus 1. Then it will be a 1 plus b over a, x to the power of minus 1. So this is going to be equal to 1 over, this is going to be equal to x over a. Then expanding this, it will be 1 plus minus 1 times b over a x. And I'm not going to go for the next term already because I've already gotten my first 2 non-zero terms. So I'm going to leave all the rest within this dot dot dot. So my first 2 non-zero terms will be this. Then this times this is going to be equal to minus b over a square of x squared, and so on. And I guess this is simple already because I just need to compare the coefficient. So by comparison, I know minus 3 is going to be equal to 1 over a. This tells me that a is going to be equal to minus 1 over 3. Similarly, minus 9 over 2, this is equal to minus b over a square. So over minus 1 over 3 square. This will help us to solve for b, and b is going to be equal to half. Okay? Yep. Good job for me. Now I am going to question number 6. Oh, 6 is actually a pretty okay question. Or at least I personally find it okay. You know why I find questions that is like 6 okay? Because there are 2 ways question number 6 can be asked. If it is asked like the way that this question number 6 is being phrased, it is very simple because you just basically need to follow the instruction. But there's of course another way to that something that is like this. The questions of this nature is going to be asked, and that is if they were to be asking you based on the idea that is behind this question. The idea that is behind this kind of question is to make use of area of rectangles to approximate the exact area under the graph. Okay, so to me, if you were to be that kind, it is a little bit more difficult because you are supposed to be discussing about the ideas. But if it is the kind that is like this, well, let's just make sure that we follow instruction and then we see how it goes. Usually that's how I'll tackle this kind of question. So I'm going to just follow what the question says, okay? So the question asks me to sum up the area of all the rectangles and show that it is going to be equal to this. So I'm going to just sum up the area of the rectangles. So for the first rectangle, the width is 1 over n. As for the height, it is going to be this. Let me use red color to indicate properly. So for the height, it's going to be this portion here. And this height can be found by the y coordinate that is at this point, right? The y coordinate at this point is when I substitute the x coordinate into this equation. So the y coordinate that is here is going to be 2 to the power of 1 over n, then plus 1. Okay, when I substitute x is equal to 1 over n into this equation. So the height is going to be 2 to the power of 1 over n plus 1. As for the second rectangle, the width is still 1 over n. And as for the height, it is going to be this portion here, which is the y coordinate at this point. So I'm going to substitute the x coordinate into this. That gives me a 2 to the power of 2 over n plus 1. Similarly, for the third rectangle, the width is still 1 over n. The height is 2 to the power of 3 over n plus 1. And I'll add all the way until the very last rectangle here. And for this very last rectangle here, the width is still going to be 1 over n. If you were to take this minus this, well, you will know that it is 1 over n. And furthermore, the question actually already told us that there will be rectangles with width as 1 over n throughout. So it will be this, then 2 to the power of 1 plus 1. So the next thing that I'm going to try to do is to recognize that this is going to be a series and sequence question. So we will try to recognize pattern. And one obvious pattern that I can see here is that 1 over n is consistent. So I'm going to just take out all the 1 over n. I'll factorize out all the 1 over n, and I am going to group all the 2 to the power of together. So I have a 2 to the power of 1 over n, and 2 to the power of 2 over n, and 2 to the power of 3 over n, and then all the way until 2 to the power of 1. And then of course I have a 1 plus 1 plus 1 plus all the way until the very last term it is also 1. And there's I'm working on from the first rectangle to all the way the nth rectangle. So there are n number of rectangles, which means that 1 plus 1 plus 1, there will be n numbers of 1, right? There will be n numbers of 1. There will be n numbers of terms here also. And for this 1 over here, you can actually see this as, if you want, it's not super necessary, but if you want, you can also see this as n over n. But because we know the pattern is going to continue, so it will be good if you can actually recognize at this point of time that this that we are working on is a GP. I can recognize that it is a GP with the first term as 2 to the power of 1 over n. The common ratio of this GP is times 2 to the power of 1 over n times 2 to the power of 1 over n. So the common ratio is 2 to the power of 1 over n. And as for the number of terms, there are n number of rectangles. So it will generate for me n number of terms here because each one of them came from one of the rectangles. So this will be 1 over n of the sum of a GP, where the first term is 2 to the power of 1 over n. The common ratio is 2 to the power of 1 over n. And the number of terms is n, then minus 1. And this is going to be divided by the common ratio, 2 to the power of 1 over n, then minus 1. Then plus, how many 1s are there? There are n number of 1s. So n time of 1. I have this. So 2 to the power of 1 over n to the power of n is 2 to the power of 1. So 2 minus 1 is going to be 1. So I will have here as 2 to the power of 1 over n times 1 divided by 2 to the power of 1 over n minus 1 plus n, which is this, right? So it is 2 to the power of 1 over n divided by n times of 2 to the power of 1 over n minus 1 plus 1. We hence shown. And then we want to try to find the limit of Sn, which is this expression over here, the limit of Sn when n tends to infinity. With the limit of Sn when n tends to infinity. I can guess that for some of us, we will definitely first try to let n goes to infinity here. But you need to do a gauge of the situation. When I let n tends to infinity here, yes, it is probably easy to discuss about this 2 to the power of this because it will just tend to 2 to the power of 0, which is 1. This is also fine, but this n, there's a little bit of problem with this n because it resides in the denominator. And there's one more thing that will make deduction that is like this a little bit dangerous is the fact that limits has been removed from your syllabus. So many times when you see something that you can probably you thought you can probably do an algebraic analysis of the limits to the expression, it may not be always it may not always be true. You know, like for example in this case here, if you were to just do this deduction, you're not going to be getting the answer. Okay, I mean in the topic of limits, there are actually a few other rules that we have not learned in our H2 math. So in case you look at the expression and you are not sure, you know, whether this is really going to become like whatever that you have thought of, my suggestion is to switch to another strategy. The other strategy is, okay, when n tends to infinity, that means I know that 1 over n, which represent the width of the rectangles, should become smaller and smaller and smaller and smaller, which means that the approximation is going to become better and better and better. And ultimately, when n goes to infinity, when the width of the rectangle becomes almost like 0, it is going to represent the exact area under the graph, which means that it is going to be represented by integration from 0 to 1 of 2 to the power of x plus 1 dx. And if you are actually able to integrate this, then that's your answer. You know, and we can integrate this because this is just going to be 2 to the power of x over ln 2, then plus x from 0 to 1. Okay, 2 marks. It is going to be this, and we need to express this as exact form. Okay, so it will be 2 to the power of 1 divided by ln 2 plus 1. Then minus away, substitute 0, it will be 1 over ln 2, then plus 0. So we have a 2 over ln 2 minus 1 over ln 2, it is 1 over ln 2, then plus 1. Long division, right, Claire? I understand what you mean, why you are suggesting long division, but my problem is actually this little n, this n in the denominator. If there were to be no n in the denominator, I think doing long division is a pretty good idea. But the problem is this n, when it is very difficult to handle this n over here. Well, that is why I think even if you have done your long division with respect to 2 to the power of 1 over n, you will still not, I don't think you are going to be getting an answer that is like 1 over ln 2 plus 1. Yes, because when n tends to infinity, the idea that is behind is when the width of the rectangles becomes super tiny, and when n tends to infinity, it becomes like a straight line. So you're just trying to add all these vertical lines together, which will represent the exact area under the graph. And for integration from 0 to 1 of this curve, it will give us the exact area under the graph, which will be a representation of this. Okay, I'm also a little bit surprised because I'm expecting some of you to be asking me how do I know that integration of 2 to the power of x is equal to this. But for me, I memorize this as a standard result. Anyway, that's why I'm going from here to here like pretty fast. Okay, but because so far I do know quite a few students who will not memorize this standard result. For the sake of the A level, please memorize this, okay? Because you can actually use this directly. But just in case some of you are wondering, you know, how can this become this? The standard result is this: integration of a to the power, integration of a to the power of x dx. this is supposed to be a to the power of x over ln a plus c, which means that if a happen to be e, so let's say e to the power of x, if you were to be applying this, then this will be e to the power of x over ln e plus c, and ln e is 1, so you get your e to the power of x plus c. Or just in case that some of you are wondering, what if you really don't remember the standard result? Because if you don't remember the standard result, there's no way that you can do a question that is like this, like really no way, because the question asks for the exact value, so you couldn't have pressed this into the calculator. So in case you really come to a scenario which you are supposed to integrate this, my suggestion is to try to rewrite this as e to the power of ln 2 to the power of x, right? Because I know e to the power of ln of anything is going to be this. You can try press into the calculator in case you have forgotten. I believe that in your secondary school you have done this before. You can press in your calculator e to the power of ln 3, you're going to be getting a 3. So e to the power of ln 2x is going to tell me 2 to the power of x is 2 to the power of x, which I can also rewrite this as e to the power of x times a number, which is ln 2x, which means that if I were to integrate via this standard result, which all of you should have memorized, this will be e to the power of x ln 2 divided by the coefficient of x, which is ln 2, then plus c. And for the numerator, I can rewrite this as e to the power of ln 2 to the power of x over ln 2 plus c, which will be 2 to the power of x over ln 2, then plus c. That's how I got this, okay? Yep. And yay, I'm now at question number 7. Question number 7 is a full integration question. Let's give it a quick try, and I once again see question number 7 as one which I am not sure how the marks allocation was planned, because I thought there should be more marks given to question number 7, but somehow just very little marks were given for certain parts, which I really don't think it is possible for anyone to very quickly come up with a set of solutions that justify the marks that is given. For example, the very first part of B. Okay, later we're going to take a look at this together. So question number 7. Question number 7, we are supposed to integrate this. I think this came out in the year 2017's A-level, so schools has been setting this a lot. And for me to integrate this, we are going to make use of what we have on in our formula sheet again. So we're going to make use of the factor theorem in our formula sheet. Please make sure that you know how to make use of this, especially when I think in the O-level, I cannot really remember. I think in O-level, they don't really give this in as the formula. I don't even think you learn this in your O-level textbook anymore. So in case you are unfamiliar with this, please make sure that you know this, okay? For A-level, it is definitely necessary that you are able to make use of this, not just going from the left to the right, but going from the right to the left. Okay, just like in this case here, we are supposed to integrate we are supposed to integrate this sine px cosine qx. We are supposed to integrate this, and I'm going to make use of the first part. And to go from the left to the right, we can actually do a very quick and simple observation. To go from the right to the left. Left to right, I think it is like pretty simple. But going from the right to the left, if I were to see this as one angle A, and if I were to see this as another angle, let's say B. So if you can just observe together with me, this P is obtained by taking A plus B, right? Half P plus half P is P. Half Q plus minus half Q is 0. So P is obtained by taking A plus B, and Q here is obtained by taking A minus B. Okay, for the same reason, if you to take this minus this, you're going to get a Q. So, which means that from here, let me just very quickly write down, what we can observe from here is that sine A plus, okay, let me write from the right to the left. So if I were to look at this, that means 2 sine A cosine B. The right hand side here, this is supposed to be sine of A plus B, then plus sine of A minus B. Okay, so for what we have here, we need a 2, so I'm going to add in a half so that I can have a 2 of sine px cosine qx dx. So this is going to be equal to half. If I were to apply this, A will be this px, B will be this qx. So it is going to be sine of px plus qx, then plus sine of px minus qx. Okay, this will be half of, let me just very quickly rewrite this into p plus q of x. And this, I'm going to rewrite it as p minus q of x. So now we have two simple expressions to integrate. And this will be half, integrating this, and not getting ourselves distracted by p plus q, which is simply just the coefficient of x. This will be minus cosine of p plus q x, then divided by p plus q. Then this will be minus cosine of p minus q x divided by the coefficient of x, which is p minus q. So I have this plus c. And this is 2 marks. Okay, which I think is fine. Okay, I think preferably it can be like 2.5 marks, but in A levels we don't talk about half marks. So I think 2 marks is fine, but I don't see how this next part can be a 1 mark question. Let's try it. Okay, I'm very surprised. If you were to ask me, I'm really a little bit surprised that 1 mark. I mean, for this, it is just going to be a 1 mark question. So we are supposed to integrate. This x sine nx dx. We are supposed to integrate this, and I guess one good way to integrate this is by making use of integration by parts. So we are going to let u be equal to x, and let's try for dv dx to be equal to sine nx. And of course, you can make use of LIATE to make this decision. And du dx here is 1, and v here is going to be equal to minus cosine nx divided by n. So this will be uv, so it will be minus x cosine nx over n minus integration of u dv dx. So minus integration of u dv dx. So minus integration of v du dx. So it is going to be this. It is going to be minus of cosine nx over n dx, which I'm going to take the negative 1 over n out. It will become positive 1 over n, which means that here it will be a cosine of nx. So this will be minus x cosine nx over n plus 1 over n. Integrating this is going to be sine of nx over n, then plus c. So this is minus x of cosine nx over n, then plus sine of nx over n squared plus c. Well, I don't think it is difficult, right? I don't think any of you found this. I mean, as long as you can remember how to do integration by parts, it is pretty okay, as long as you're not distracted by the coefficient, and it is really pretty okay. But 1 mark, I'm not pretty okay. I feel that it is like really stingy, okay? They should have given at least 2 marks to this. So anyway, we have proven this, and we are going to try to make use of this result to do part 1 and part 2. So B part 1. B part 1, we are supposed to find integration, a definite integral from 0 to pi of x sine nx dx. Okay, and I'm going to make use of this result, which means that this will be minus x cosine nx divided by n, then plus sine of nx divided by n squared from 0 to pi. Okay, so if I were to substitute numbers in, it will be minus pi, then cosine n pi divided by n plus sine n pi divided by n squared. Minus away, substituting 0 in, this will become 0, plus substituting 0 in, because 0 times x, so it becomes 0. Substituting 0 in, it will be sine 0, which will also be 0. Which means that we will be left with a minus pi cosine of n pi over n plus sine of n pi over n squared. And the question tells me that n is a positive integer. So how are we going to consolidate this into a k pi over n? My suggestion is, it is not difficult, but in case you cannot see, my suggestion is you try to draw a graph. You try to draw a graph of cosine and sine. For example, if I were to draw a graph for sine, if n is a positive number, then if I were to draw a graph for sine, let me draw a few periods here. What you realize that it is when n is equal to 1, that is when the angle here is pi. Sine of pi is 0. Sine of 2 pi, it is 0. 3 pi, it is 0. 4 pi, it is also 0. And that is why I know the numerator here. For sine of n pi, where n is a positive integer, this will be 0 all the time. For cosine n pi, it is the same. If I were to just do a quick sketch of cosine, this we have a 1 period, then another period, then another period, and you will realize that for pi, it is minus 1, and when it is at 2 pi, it is at positive 1. When it is at 3 pi, it is at minus 1. When it is at 4 pi, it is going to be at 1. So it is going to be toggling between 1 and minus 1, 1 and minus 1. That is why this here is going to be either 1 or minus 1, plus or minus 1. And so we have a minus pi of this is plus or minus 1 divided by n, and this is always going to be equal to 0. So we have a plus or minus pi over n. And looking at this, what are the possible values for k? We know k here is going to be plus or minus 1. Okay, this is for part 1. And as for part 2 is again a tedious question. For part 2, we have integration of a modulus, and if you have checked out what I've written on Achevas TV, we cannot integrate something with a modulus, so we need to find a representation of this integral as if it is an area under the graph for us to analyze. So in order for us to do this, I've already drawn the graph, and I've drawn the graph without the modulus. Let me show you the graph that I've drawn. Okay, so I've gotten this. I drew this without the modulus, so I've drawn the graph of y is equal to x sine 3x. Okay, the graph without the modulus, which means that when I'm dealing with the modulus, of course, whatever that is below the x-axis is going to be reflected, and since we are working on definite integral, we are working on areas. Okay, so I know this part here is going to be reflected. When here I have planted in pi over 0 to pi over 2. So I've planted in pi over 2, which is 1.570, blah, blah, blah. So this here, which is when x is equal to pi over 2. So basically, this integral is representing this area here, multiplied by this area here. And for this blue colored area, the equation that represents this area is y is equal to x sine 3x. And as for this red colored region here, this red colored region, which is the reflected region, this red colored region will have an area that is represented, which is the area that is below this graph, which is a reflection of this blue colored graph about the x-axis. So it will be y is minus x, then sine 3x. Okay, so we have these two graphs where we are seeing this as if it is the area under this graph and this graph. Okay, so this graph, the red colored graph here, okay, which has the equation of this. So now I can try to represent this integration from 0 to pi over 2 modulus of x sine 3x. Well, I'll represent this by integrating from 0 to this number here. And to find this number, we will let x sine 3x be equal to 0, which means that x must be equal to 0, which is definitely not this number, in fact it is here, or sine 3x to be equal to 0. And if I were to try to find an x that is between 0 to pi over 2, that x will be pi over 3. So this x here is pi over 3, which means that for this first region here, it is going to be integrating from 0 to pi over 3. And please remember, we are doing this because we cannot integrate something with a modulus unless we are allowed to press the calculator. Okay, but this question didn't allow us to do that because it is a hands question and we are supposed to answer this in terms of pi. Okay, so we need to do this integration manually. So we'll be integrating this x sine 3x dx, then plus integration from pi over 3 to pi over 2 of this other graph, which is minus x sine 3x dx. And I'm going to make use of this result by replacing n, which represents positive integer. In this case, I'll represent n by 3. So this that is here, representing n by 3, it will be minus x cosine 3x over 3, then plus sine of 3x over 3 squared, that is 9, from 0 to pi over 3. Minus, I think I'll just take it out. So this is going to be a tedious process. Cosine of 3x divided by 3 plus sine of 3x divided by 9 from pi over 3 all the way until pi over 2. So substituting this in, it is going to be minus pi over 3 cosine pi. 3 times cosine pi. Cosine pi is minus 1. So let me just rewrite it as minus 1. So minus 1 divided by 3 plus sine 3 times of pi over 3 is sine pi. And just now we saw on the graph, sine pi is 0. So we have a 0 over 9. This is the first one. Then minus away, substituting 0 in, this is going to be 0. Then sine 0 is also going to be 0. So the whole thing is 0 for the second part. Minus away this, when I substitute this in, we have a pi over 2 times cosine of 3 pi over 2. Cosine 3 pi over 2 is 0. So let me just write it as 0. Then plus sine of 3 pi over 2. Sine 3 pi over 2, sine 3 pi over 2 is minus 1. So we have a minus 1 over 9. Then minus away. Substituting this in, I have a pi over 3 times cosine pi, which is minus 1. Then divided by 3 then plus sine pi, it is 0. So I have this. And if you were to evaluate this, you will be getting this as a 2 pi over 9 plus 1 over 9, which you can of course rewrite it as 2 pi plus 1 over 9. And I'm going to just quickly press this into the calculator and verify that it has the same numerical value as 2 pi plus 1 over 9. Then I know everything so far has been correct. Okay, let's take a look at this question, this complex number question. Question number 8. Okay, we are not supposed to be using our calculator, and we are supposed to solve for this pair of simultaneous equation. And when it comes to simultaneous equation which has complex roots, for example, like this case here, let's make sure that we don't randomly try to do our elimination and substitution, because for this pair of simultaneous equation that we are looking at here, we know elimination and substitution, they are not going to work. Why will they not work? Because we have two equations, but within these two equations, there are actually three unknowns: W, Z, and W conjugate. For the way that we have learned simultaneous equation in our secondary school, two equations is supposed to help us to solve two unknowns. It is not about W, it is not about Z. It is really about having three unknowns in two equations. That is why this question has to be planned. And if I were to do substitution and elimination, what we should try to do is to put terms that are as similar as possible together. So in this case, I guess one good strategy is to try to put Z and Z conjugate together, because although they are different, but at least they are still related, somewhat related to each other. So let me start with this. My plan is this: W minus 2Z, this is equal to 9. I'm going to make W the subject. So W is going to be equal to 9 plus 2Z. And my plan is to substitute this into the second equation. This 3W minus WZ conjugate is equal to 17 minus 30I. So I'm going to call this equation number 2, and I will substitute equation number 1 into equation number 2, because I am planning to get an equation where I have Z and Z conjugate together. So let me place equation number 1 into equation number 2. So we have 3W. W is 9 plus 2Z minus W times Z conjugate. So that will be 9 plus 2Z multiply by Z conjugate. This is equal to 17 minus 30I. So expanding this, we have 27 plus 6Z minus this will give me a 9Z conjugate, then minus 2Z multiplied by Z conjugate. This is equal to 17 minus 30I. Hang on, give me a second. Let me do some adjustment here. Okay. So it is not necessary, but I'm going to bring 27 over to the other side. So I will be left with 6Z minus 9Z conjugate minus 2Z multiplied by Z conjugate. This is equal to minus 10 minus 30I. And we know this is an equation that I cannot continue because there are two unknowns in one single equation. So, but by making use of the fact that Z and Z conjugate, they are related to each other, we will let Z be equal to, let's say, A plus IB. And according to this question, the real part of Z is supposed to be less than 0. The real part of Z is A. So when I let Z be equal to A plus IB, I know A is supposed to be less than 0. So we have 6 multiplied by A plus IB minus 9 multiplied by A minus IB minus 2 times of Z times Z conjugate. A plus IB multiplied by A minus IB. That will give me A square plus B square. This is equal to minus 10 minus 30I. I think this question is still not too bad. For some of you who told me just now that one guy told me that he gave up, and then Alvin said that we really cannot underestimate the examiner. I think it is not so much of for this question, but for the subsequent, I think question number 9 and question number 10. So anyway, I'm going to try to regroup this. So that will be I will have a 6a plus 6a plus 6b I minus away 9a plus 9bi minus 2a square minus 2b square. This is minus 10 minus 30i. To group all the real parts together, so all the non-i's together, we will have a minus 3a minus 2a square minus 2b square. Then to group all the i's together, it will be this and this. So this gives me a 15. This gives me a 15b. And this is equal to minus 10 minus 30i. Okay, now we can compare the real to the real portion on the left hand side to the right hand side, and the imaginary to the imaginary. So we have a 15b is going to be equal to minus 30. This helps me to solve for b. B is equal to minus 2. And I can substitute b back into here and matching this to minus 10 to solve for a. And let's not forget that a is a number that is supposed to be less than 0. So we have a minus 3a minus 2a square minus 2b. b is minus 2. So minus 2 square. This is equal to minus 10. Simplifying this, we will have a 2a square plus 3a minus 2. This is equal to 0. Factorizing this, we will have a plus 2, then 2a. 2a minus 1. This is equal to 0. So a is minus 2, or a is going to be equal to half. And since a is supposed to be a negative number, we are going to be rejecting a is equal to half. Therefore, we know for this case here, z is going to be equal to minus 2a, and b is minus 2. So minus 2 minus 2i. And we have w. W is here. So we are going to substitute z back into w. This tells me that for w, this is 9 plus 2 times of z, minus 2 minus 2i. So w here is going to be equal to 5 minus 4i. It is not too bad, but I think it is a little bit tedious for a 4 marks question. That little bit tedious, but still okay. Next, let's move on to b. b, we have a cubic polynomial with complex coefficient. Which means that if minus I is a root, we cannot immediately conclude that positive I is also going to be a root. Because for a complex number to be a root and then the conjugate is also going to be a root, that is only applied to polynomials with real coefficient. So not so for this case. We are supposed to determine the value of k, and then we are supposed to find the other roots. K is good. I mean, minus I is already going to be one root, which means that we are going to be finding 2 other roots. Because this is z to the power of 3, it means there will be a maximum of 3 roots. Okay. Let's plan a little bit, okay, how we should find k. Since we know that minus I is a root, so we can try to make use of the factor theorem. If I were to make use of the factor theorem, we can substitute and replace z that is from the equation. We can substitute z by minus I, since minus I should satisfy the equation. And with that, we probably should be able to solve for k. Let's give that a try. So b part 1, I am going to substitute minus I into this. So is there something? Okay, so we will have this as a minus I. Hang on. Okay. So we will have a minus I to the power of 3 plus k times of z squared. So minus I square plus 8 plus 2 square root of 2i. And this we multiplied by z. Z is minus I. So this plus 8i, this is equal to 0. So minus I to the power of 3, this is equal to I. Then minus I squared, this is going to be equal to minus 1. So minus k. Then plus 8 times minus I, oops, this is going to be minus 8i. Then 2 square root of 2i times this, it is going to be positive 2 square root of 2 plus 8i, this is equal to 0. I guess we can find k. K here is going to be equal to 2 square root of 2 plus I. So we have found k, which means that this equation is z to the power of 3 plus k. K is 2 square root of 2 plus I. Then z square plus 8 plus 2 square root of 2i, z plus 2i is equal to 0. And in order for us to find the other roots, what I'm going to try to do is to factorize, is to factorize the expression that is on the left hand side first. And I know one of the factors will be z minus I, by using the factor theorem. So what I think I'm going to try to do is to do a comparison to find the other roots. So, sorry, I want to use comparison to find the other factor, which means that this, one of the factor is a linear factor, which is z minus I, so z plus I. Which means that the other factor, because this is z to the power of 3, the other factor is going to be a quadratic factor. So for the quadratic factor, I'm going to assume it to be az squared plus bz plus c. Okay, so for the z squared term, since this is z to the power of 3, this is z, so it should be 1 time of z squared. And for the constant term, the term that is independent of z, because I multiplied by this term should be giving me an 8i. So here it should be positive 8, which leaves me with this, and this is going to be, I'm going to let the coefficient be, let's say c, since a and b I've already used here, so I'm going to just call it c, let's say cz. I'm going to try to compare coefficient, for this and this to try to find c, and I think I'm going to make use of the coefficient of z. So let me try to compare coefficient of z on both the left and the right hand side. On the left hand side, coefficient of z is 8 plus 2 square root of 2i. And on the right hand side, to get coefficient of z, it will be z times, it will be z multiplied by 8. So it will be 8, and then it will be I multiplied by cz. So it will be plus I c. So with this, I should be able to solve for c. C here, 8 and 8 can be cancelled, I can be cancelled, which means that c here is going to be 2 square root of 2, which means that for z to the power, for z to the power of 3 plus blah 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 is equal to 0, this can now be factorized to z plus I, and z squared plus c. C is plus 2 square root of 2 z plus 8. This is equal to 0, which means that z plus I is equal to 0, z is equal to minus I, which is the root that is already given to us. Or another possibility is when z squared plus 2 square root of 2z plus 8, this is equal to 0. For this, I guess I am going to try to solve for it using the quadratic formula. So it's going to be equal to minus b plus or minus square root of b squared minus 4ac, this divided by 2a. So we have this, and this is minus 2 square root of 2 plus or minus this is square root of minus 24 over 2. So we have this as minus 2 square root of 2 plus or minus square root of minus 24 is 4 times 6 times minus 1. So it is going to be 2 square root of 6 times I, and this divided by 2. So the other two roots will be this divided by this. This gives me minus square root of 2. This divided by this is plus or minus square root of 6i. So what are the other two roots? The other roots are minus square root of 2 minus square root of 6i and minus square root of 2 plus square root of 6i. Okay, these are the other two roots. Let me write them down here. So for this, I have three roots. One is already given to me by the question. One is minus I. And for the other two will be z is equal to minus square root of 2 minus square root of 6i. And then minus square root of 2 plus square root of 6i. Okay. Next, here. Do you remember when we were doing the ACJC? I think that was the ACJC, right? When we were doing the ACJC, I told some of you who probably are here also, a strategy that we can make use of to solve this specific kind of question. So I'm going to use that same strategy that I mentioned a few weeks back, okay? So for B part 2, okay, with this as the result, and we know K over here is, let me just write K. So for this, K is equal to, we have already solved for K, right? K is equal to 2 square root of 2 plus I. Okay, let me erase this first. So I'm going to use the same strategy. Let's see whether you will be able to get it. Joe, you have used the strategy. It's a very consistent strategy. I was also talking about it during my tuition class. So if some of you are attending my tuition class, I would really suggest and recommend that you guys try to make use of this strategy, okay? So the strategy is this. For part 2, okay, we are going to make use of the strategy that I've mentioned. It's a very, very consistent strategy. So hence, we are supposed to solve for this iz to the power of 3 plus k. K is this, so plus 2 square root of 2 plus I. Okay, of z square plus 2 square root of 2 minus 8i. Z minus 8i, this is equal to 0. And we know the nature of this kind of question because we know that this, to find the answer for this, it is not requiring us to solve this all over again. It is trying to make use of the previous equation. So if I were to make use of the previous equation, I'm expecting that the z that is from the previous equation is going to be replaced by some other compounded expression in terms of z, which means that for this equation, if I have manipulated it correctly, it should end up with something that is like this. You should end up with something to the power of 3, just like this. Okay, except that this z is going to be replaced by something, okay, which is what we're going to try to derive, okay? So it is going to be this plus k. K is this 2 square root of 2 plus I. Then z square plus 8 plus 2 square root of 2i. Then z plus 8i is equal to 0. So the strategy is, oops, I wrote wrongly. I have actually literally recopied again. So my intention was to that all this z here is supposed to be replaced by something. So I'm supposed to find this. So this plus 8i, okay, and this is equal to 0. Did I write it correctly? Oops, I wrote it wrongly. So this is supposed to be k, which is this, then square. Then after that, this is supposed to be 8 plus 2 square root of 2i of z plus 8i. This is equal to 0. Oops, I did it again. Here this should be equal to z. Where this z should be something, okay, which we are trying to find a replacement for. So this equation is supposed to be written into this form in order for us to find what are we actually supposed to replace it z with. So what I was saying that was that a lot of people found this difficult if they cannot immediately observe what z is going to be replaced with. And the reason why they found it difficult was because they try to observe exactly what z is trying to replace with. And that can be quite difficult. And what you can try to do is, instead of working on, if you are trying to look at z and asking yourself what z should be replaced with, and you found it difficult, my suggestion is you don't try to work on z first. Because that is the one that you have already found difficult. One of the, what you should try to do is to work on the term that is independent of z. Where this is what that is going to create for us the consistency, which means that looking at this equation, to have the consistency between this and this, it must end with a plus 8i, and this is minus 8i. So I'm going to take this whole equation and I'll multiply it throughout by minus 1. So I have a minus I z to the power of 3 plus minus 2 square root of 2 minus I, then z square, then plus minus 2 square root of 2 plus 8i, then z, then I have a plus 8i. This is equal to 0. So I start to synchronize based on the term that is the most independent of z. Then the next one I'm going to try is this z. How can I re-express this so that the coefficient becomes 8 plus 2i? So I guess one obvious thing that is probably that I should multiply, I should factorize out z. I should factorize out I. So if I were to factorize out I and try, this is supposed to be I z. Then, so I have a 8i, this is equal to 0. So 8, it should synchronize with this already. And if I were to factorize out I, then this should be a plus 2 square root of 2i, correct? Because this multiplied by I is going to give me a negative 2. So with this, I'm suspecting that all the z is supposed to be replaced by iz. I'm going to do a test. What if this is supposed to be replaced by iz? So if this is supposed to be like this, then will the coefficient be 2 square root of 2 plus I? Yes, because I square is going to be minus 1. Minus 1 multiplied inside, I'm going to be getting this. Which means that I'm also suspecting that this can be re-expressed as iz to the power of 3. And iz to the power of 3 is minus I z to the power of 3. So with this, by working from the behind to the front, by working from the term that is independent of z, then I've managed to observe that I'm going to be replacing all the z by iz. Okay, so now I know that all the z is going to be replaced by iz. So iz is going to be equal to minus I, or iz is going to be equal to minus square root of 2 minus square root of 6i, and iz is going to be equal to minus square root of 2 plus square root of 6i. We have a very good and consistent strategy. So z here is going to be equal to minus 1, and if I were to multiply by minus I on the left hand side, it will become z. I'll multiply by minus I on the right hand side. That will give me a minus square root of 6 plus square root of 2i. Similarly, if I were to multiply by minus I on the left hand side, I'll get a z, and on the right hand side, I'll be getting a square root of 6 plus square root of 2i. Okay, the strategy is to start with the term that is independent of z, and we try to make the term that is independent of z look like look like the original equation. Then we try to work from here towards the front. It is usually going to be easier. Okay? Next, let's look at part 3. For part 3, we are looking at Z0, and according to the question, Z0 is going to be one of the roots from part 1. Z0 is one of the roots from part 1, such that the argument of Z0 is supposed to be bigger than 0. So there are 3 roots from part 1. Minus I. Minus I has an argument that is negative, because minus I on an Argand diagram, it is represented by a point 0 minus 1. So the argument is minus pi over 2. As for minus square root of 2 minus square root of 6i, if I were to sketch this on an Argand diagram, it is going to be represented by a point that is on the third quadrant. So minus square root of 2 minus square root of 6. and the argument is going to be negative. We are looking for an argument that is positive. So that leaves us with minus square root of 2 plus square root of 6i. So if I were to sketch this on an argand diagram, it is going to be represented by a point here. The argument is positive. So we are going for z0 to be equal to minus square root of 2 plus square root of 6i, since its argument is positive. And I'm going to be analyzing the complex number iz0. So let's find this complex number first. We have a I multiplied by minus square root of 2 plus square root of 6i. So this multiplied by this gives me minus square root of 6. This multiplied by this, it is minus square root of 2i. So iz0 is this, and we are going to be looking at iz0 to the power of n, in which we are going to try to convert this entire complex number here into the re to the power of I0 form. We are going to try to convert this entire complex number here into the form of x plus iy, or re to the power of I theta. And to do that easily, we will try to first change this into the re to the power of I theta first, before we power n on iz0. So I'm going to try to convert this into the Euler form by finding modulus of this, which is going to be square root of minus square root of 6 square plus minus square root of 2 square. This is going to be equal to square root of 8. The argument, let's try to make sure that we do a quick sketch on an argand diagram. It is going to be represented by a point that is in the third quadrant. So it is minus square root of 6 and minus square root of 2. The argument is this. So the argument of iz0, this is going to be equal to minus pi plus the basic angle. The basic angle is going to be square root of 2 divided by square root of 6, which is 1 over square root of 3. This is a special angle. So this will be minus pi plus pi over 6, which gives us a minus 5 pi over 6, which means that iz0 is square root of 8 e to the power of minus I 5 pi over 6. So iz0 to the power of n, this is going to be square root of 8 e to the power of minus I 5 pi over 6. And let's make use of the power of the Euler form, which allows us to manipulate complex number as if it is just multiplication and indices. So this will be square root of 8 to the power of n. This is a real number. Then applying indices, this is going to be minus I 5n pi over 6. And according to the question, this complex number here, iz0 to the power of n, is purely imaginary. Okay, if this is purely imaginary, that means the real portion must be equal to 0. I'm going to adopt the same strategy as what I've introduced on the Achevas TV on the theory outline. I talk about the situation when a complex number is purely real and the situation when the complex number is purely imaginary. And to make use of that, I'm going to re-express this into the x plus iy form, the Cartesian form. That will be square root of 8 to the power of n. Then cosine of minus 5n pi over 6 plus I sine of minus 5n pi over 6. And since the question says that this is purely imaginary, which means that the real portion must be equal to 0. So we will be letting the real part of this be equal to 0. So we will be letting cosine of minus 5n pi over 6. I'll be letting this be equal to 0. And if you were to check out what I have written on the Achevas TV theory outline on complex number, there's a formula for this angle. So I'm going to apply that formula, minus 5n pi over 6. This is equal to odd number multiplied by pi over 2. So if this is an odd number, that means k is going to be some integer value. The question asked me for the smallest possible n. Smallest possible n such that this is going to happen. So if I were to make n the subject here, n is going to be equal to minus 3 over 5 of 2k plus 1. How are we going to find the smallest positive integer value of n? We are going to just literally substitute and replace k by integer values. You can either do it manually or you can just simply press it into the calculator. Let me show you what I mean by pressing into the calculator. I can press this into the calculator. Wait, that means I press this entire expression here into the calculator, replacing k by x. And I will just let my calculator do the substitution. Oh no, what happened? Okay, I'll just let my calculator do the substitution, which is going to be this. Okay, my calculator did the substitution. And what I need to do is to just see what are the values of n that is going to give me, and what are the values that's going to give me this as an integer value. Okay, because all these values here are going to be representing different integer values of k, and I can see that when k is equal to minus 3, it is going to give me 3. When k is minus 8, it's going to give me 9. I will scroll up, I will scroll down, I will list down a few numbers here. Those numbers will be numbers like minus 9, minus 3, 3, 9, 15, and so on. Okay, because one question that I usually get, when it comes to something that is like this is, are you sure you are supposed to do substitution? Yes, you are supposed to do substitution. So, and I guess one reason why sometimes we don't really want to do substitution is because isn't it like very difficult? How do you know what values of k you are supposed to substitute in? Because if you to substitute, for example, k to be equal to like minus 2, which is an integer value, you're going to get a 1.8. So how are you going to do that fast? Use your GC. Use your GC, generate a table. From the table, extract out only the integer values that synchronize to what the question wants. And the question wants smallest positive integer value of n, which is going to be this. So immediately from my GC, with the list of numbers that my GC lists down for me, I know that the least possible, the smallest, okay, the question says smallest, the smallest positive integer value of n is equal to 3. Okay. Next, let's look at question number 9. It is a function question. And question number 9b is the one that I feel it is sort of like a little bit hard to tackle as an exam question. So I am really questioning what is the motivation of whoever set the question. Why is it that the question was set that way? But I'm glad that at least A is a pretty easy question. So let's take a look at 9a first. Then after we see how challenging 9b is going to be. Okay, let me erase this. Oh, by the way, please make sure that you know how to do something that is like B part 3. It is going to be a very, very popular kind of question for prelim. So I'm expecting, for those of you who are sitting for your prelim in a few weeks time, so please make sure that you know how to do this kind of purely real, purely imaginary question, where it is going to be very, very popular because A-level has set it in the recent years. Actually, even before A-level has set it, it has already been very popular amongst schools. So let's make sure, okay, we know exactly the process of how to solve for this kind of question. And for this particular question, we are just using one of the few methods that can be used to solve for this particular kind of question. And for those of you who are from my tuition class, please remember, okay, we have 2 other methods. So in total, we have 3 methods to tackle this kind of question. I don't have a chance to show all of them here, but please remember, okay, there are 3 methods. But anyway, let's take a look at question number 9. Question number 9, part 1 and part 2, they are pretty simple. So let's take a look at question number 9, part 1. We are supposed to sketch a graph. We have a small little twist that is added by the question, but I don't think it is that bad. The twist is instead of giving us fx, we are given 1 over fx, and we are supposed to sketch the graph of y is equal to fx. Let's try it together. According to what the question says, this is the graph of y is equal to 1 over fx. When x is equal to 0, x is equal to 2, they are asymptotes which we can see. And y is equal to 1 is the horizontal asymptote. There's a turning point here. This turning point here is 1 and minus 2. And we must know that 1 over fx and fx, they are just simply reciprocal of each other. So the way to sketch fx from 1 over fx is almost entirely the same as how you would have sketched 1 over fx from fx. So let's try to work first on the asymptotes. I have a horizontal asymptote y is equal to 1. So on fx, which is a reciprocal of this, or I mean in a way, you can also try to see this as maybe gx. Okay, and they are asking you to sketch this. So I can see this as sketching 1 over gx. So the first thing that I'm going to do is I'm going to focus on all the asymptotes. So horizontal asymptote y is equal to 1 will continue to be a horizontal asymptote of y is equal to 1. Vertical asymptote will become x-intercept. Furthermore, that's what the question has mentioned here also. So from here, I know it is going to pass through, fx is going to pass through the point 0, 0. Fx is going to pass through the point 2, 0. So it's going to pass through this point here. It's going to pass through the origin. It's going to pass through another point, let's say here. And this is going to be 2, 0. And I'm going to work on, the first thing I'll do is I'll try to work on all the asymptotes. The second thing that I'll do is I'm going to try to work on all the xy intercept, which there are none here. Then the third thing that I'm going to do is I will just do an analysis from the left to the right. A few weeks ago, I remember we were doing 1 over fx, and I showed you guys also what I meant by analysis, which can be a very simple process if you were to do your analysis based on arbitrary points that you can assign to this graph. For example, if you were to assign a point that is all the way to the left, so let's say minus 1000, and the y coordinate is a little bit more than 1, so this can be for something that is like, let's say 1.1. When it is being transformed onto the graph of y is equal to 1 over gx, that means when x is equal to minus 1000, gx is going to be 1.1. When x is equal to minus 1000, gx is going to be minus 1000. 1 over gx is going to be 1 over 1.1. And 1 over 1.1 is smaller than y is equal to 1. So I know that this point here will be transformed to somewhere here. Then it is going to be connected to this. So from here, it is going to be connected to this point. Okay, I think I better draw this properly. So it must be tending towards the horizontal asymptote, then come to this point. Then you'll go to this point, which will become a point 1 and 1 over minus 2. 1 over the original y coordinate. So it's going to go to a point. Let's say here, it is 1 and minus 1 over 2. Then you'll come back to this point. And similarly for here, if I were to choose a point here, it will be like 1000 and 1.1. And it will become 1000 and 1 over 1.1. 1 over 1.1 is going to be less than 1. So it's going to be a point that is somewhere here. So from here, it will turn up and tend towards this asymptote. This will be the graph of y is equal to 1. This will be the graph of y is equal to 1 over fx. This will be the graph of y is equal to fx. This is part 1. Okay, a simple question. Next, part 2. Part 2. For part 2, I want to find we have the function f, and now f inverse exists. For what it is currently, f inverse does not exist because you failed the horizontal line test. So for f inverse to exist, x must be bigger than k. So x must be bigger than a certain value, and I can see that as long as I can restrict my graph to be on the right hand side of this symmetrical graph, that means for this red colored region here, then I'll be getting a graph that is going to pass the horizontal line test, which means that as long as f adopts something that is part of this, f inverse is going to exist for x to be bigger than k. So k can be here, k can be here. The smallest possible k can go will be this number here, which is 1. So for this, what is the smallest possible value of k? The smallest possible value of k is going to be equal to 1. On the same graph, we are supposed to sketch the graph of fx and f inverse x. This is easy too. Let's quickly get over this and then we can work on B, which I am not sure whether you guys will be asking me questions because I will find it a bit difficult to explain B. So anyway, let's just focus, okay? Let's just focus and get part 2 done first. So part 2, let me put this here. So let's try to sketch the graph of f and f inverse. The first thing that you should try to do is definitely to sketch in the graph of y is equal to x, because you are trying to display the geometrical relationship between f and f inverse and their reflection about the line y is equal to x. So let me draw in the 45-degree line, y is equal to x. So I have this all the way, and this is y is equal to x. And I'm going to be taking this part of the graph and then transferring it to here. So there's a horizontal asymptote y is equal to 1. So I have this horizontal line here, y is equal to 1. And when x is equal to, and when and k is supposed to be, x is supposed to be bigger than k, and we are supposed to make use of this value of k, which means that we are talking about fx such that x is supposed to be bigger than 1, strictly bigger than 1. And 1 is actually the intersection between y is equal to 1 and y is equal to x, correct? So 1 is going to be directly below this. And in fact, because we are going to be sketching the graph of y is equal to f inverse x, this horizontal asymptote is going to be reflected as a vertical asymptote on the graph of y is equal to f inverse x. So let me just draw this vertical asymptote first. I think it is going to be a good reference for us as we fill in the details of both graphs. So this, we have it as x is equal to 1. So let me sketch the graph of y is equal to fx. It's going to be starting at this point, and it is going to be a hollow dot because x is supposed to be strictly bigger than 1. This point here has a coordinate of 1 and minus half. So from here, I have my graph tending towards the horizontal asymptote, and this point here is 2, 0. Reflecting this point up, I will have a point here, which is going to be minus half and 1. We will just swap the x and y coordinate, and then this is going to be somewhere here, which will be at the point 0, 2. So my graph is going to look something that is like this, tending towards the vertical asymptote. Okay, this will be my graph of y is equal to f inverse x. And this is going to be the graph of y is equal to fx. Okay. Okay, and now we are going to look at B. Anyone has tried B? And how do you find question number 9B? I sort of remember this question number 9B because I remember last year a student actually asked me this, an ACJC student actually asked me this question after his prelim. So question number 9B part 1. If anyone has already tried question number 9B, let me erase this. Part 3 is weird. Yes, I totally agree. Part 3 is not just weird. Part 3 is extremely weird. The last part of this one is very, very weird. Anyone else tried question number 9B? Specifically 9B. I think 9A is like really very simple, but 9B is a challenge, I think. First of all, we are supposed to fill in the blank. so let's try to fill in this blank together, okay? We know G is defined as this, where n is an integer value, okay? So if now g is seen as a piecewise function, looking at this, I can get a bit of inspiration from the format of this to see that to get a 1 over 4, that is when n is equal to 2. To get a 1 over 2, that is when n is equal to 2 again, correct? Which means that to get this, it is when n is equal to 2. So this synchronized to 1 over 2 to the power of 2, and this synchronized to 1 over 2 to the power of 2 minus 1, which gives me this. So if n is equal to 2, if I were to fill in the blank, this must be 2 to the power of 2 x minus 1, which is going to be equal to 4x minus 1. I'll do the same thing for this. To get a 1 over 2, it seems like it is 1 over 2 to the power of 1. To get a 1, it seems like it is 1 over 2 to the power of 1 minus 1, which is 1 over 2 to the power of 0, which gives me a 1. Which means that to get this, n is equal to 1. So this will be 2 to the power of 1 x minus 1. This is 2x minus 1. Really not bad for just filling in the blank. Oh, okay, I misinterpreted. I thought this is 3 marks, but I guess this is probably just 1 mark. Okay, because we are supposed to sketch a graph also. So I think the graph is probably going to be 2 marks. Okay, most likely it's going to be 2 marks. Let us try to sketch this graph, which is going to be essential for us to work on when we try to do part 3 of the question. So for this graph here, we are supposed to sketch from 1 over 4 all the way until 1. So 1 over 4 all the way until 1, we'll be sketching this. From 1 over 4 to 1 over 2, the graph is going to be taking the form of this. And that will look something that is like this. Let me try to sketch, okay? So when y is equal to 0, x is going to be 1/4. So it is going to start at 1/4. And it is going to end at half. So half is maybe somewhere here. And when I substitute half inside, I have a 2 minus 1. So I will end at 1. So let's say it is here. Where I'll end at the point half 1, which I'm going to be using a hollow dot because it is strictly less than half. Here, because it is bigger or equal to 1/4, I'm going to use a solid dot. So my first portion of the graph, which is a straight line, is this. And the second portion of the graph starts from half. And when I substitute half inside, I have a 1 minus 1, which is 0. Or you can definitely just simply press this into your GC. It is going to be a solid dot. When I substitute 1 in, it is 2 minus 1. I'm going to get it 1 as an output. So I'm going to be ending at 1. So this is half, double the distance. Let's say it is here, 1. And I will be ending at this point here, which is at the same horizontal line. This is going to be at 1, 1. So my graph is going to look something that is like this. Okay, this will be my graph of y is equal to gx. Maybe let me just do a little bit of dotted line so you can see that the geometry is something like this. Okay, I'll just put some faint dotted lines here. It is for our reference. I don't think it is necessary for us to be putting this dotted line into the graph. As long as we indicated the coordinates properly, making sure that they are lying on somewhat the same horizontal line, that should be fine. Let me put another small little reference here. Okay, next, part 2. This is part 1. Part 2, let me try to write here. Part 2, we are supposed to show that gx is equal to gx over 2. So let me work on gx over 2. For gx over 2, I know that it is going to be equal to this, where x is going to be replaced by x over 2. So if I were to replace x by x over 2, we have a 2 to the power of n, then x over 2, then minus 1. And let's not forget that we are going to be replacing all the x by x over 2, including the x that is in the domain here. So it is going to be this, where x here is going to be replaced by x over 2. So this is going to be bigger or equal to 1 over 2 to the power of n. This is going to be strictly less than 1 over 2 to the power of n minus 1, which means that I will be getting a 2 to the power of n minus 1 times x minus 1, correct? Because it's 2 to the power n divided by 2, so 2 to the power of n minus 1. I'm going to multiply 2 throughout this inequality, which gives me a 2 over 2 to the power of n. This is bigger or equal to x. This is strictly less than 2 over 2 to the power of n minus 1, which then gives me a 2 to the power of n minus 1, x minus 1. If I were to move the numerator into the denominator, I'll be getting a 1 over 2 to the power of n minus 1. Bigger or equal to x, less than, moving this to the denominator, I will have a 1 over 2 to the power of n minus 1 minus 1. And n is an integer. I'm going to replace n minus 1 as a notation m, which will also be an integer, right? Because if n is an integer minus 1, it is still going to be an integer. So I'm going to go for this minus 1. So this n minus 1, I will go for m as a notation. n minus 1, I'll go for m as a notation, where m here represents n minus 1, and it is still going to be an integer, which means that what I've gotten now for this, it becomes a form that is like this, which is exactly the same as this, where n is an integer, where m is an integer. Therefore, this is gx, and I've taken care of both the expression and the domain, showing that they are exactly the same. That is why I have shown that gx is equal to gx over 2. So from here, shown. Okay. And part 3. Part 3 is going to be the one that is, I don't know, I find it potentially hard to explain. Okay, I'm not very sure. Usually you guys have a lot of questions when it comes to this kind of question. So in case you guys start asking and I'm not able to answer all of you, I mean, just pardon me, okay? Because I'm going to try to talk about this as clearly as I think I can try to explain. Then I want to move on to the next question, because the next question is also very difficult to explain. So okay, part 3. Part 3, I want to find the number of solution of gx is equal to x, where x is between this number to this number, 0.001 to 1. Okay. And the thing is, this equation here, right, is actually telling us that the graph is going to be repeating both to the left hand side and to the right hand side, because every time when you scale it by half, it is going to be the same thing. Sorry, every time when you scale it by 2, it is going to be the same thing. So going to the left, you just need to make sure that it becomes smaller and smaller by 2. Going to the left, going to the right, you make sure that it becomes bigger and bigger and bigger by 2, where it is going to represent exactly the same thing, because this can also be seen as g2x is equal to gx. So the graph is actually, for part 2, right, the graph is actually going to repeat to the left and it's going to repeat to the right. Okay, and that is why for this question here, the number of solution between gx and x, if I were to just try to sketch x onto here, it is going to pass through the origin and it's going to pass through 1, 1. So this line here is going to be something that is like this. This is the line y is equal to x, but because of the repetition of the graph, the answer here is not 1. This is a hollow dot, so this is not considered as a solution. So this is going to be a solution because it is going to be where this line cuts the graph of gx. So if you are looking at just this graph alone, it is just going to be 1 solution. But because of the repeating nature of the graph that is shown in part 2, we need to try to visualize what if the graph goes to the left hand side. Why left hand side? Because x starts from 0.001 all the way until 1. So we are looking at a very small value all the way until 1. It stops here. if it is the one that is before this, let me try to show you how you can visualize it, okay? From half and sloping this way, it become 1/4 and sloping more. And then the next one, if you go and calculate, it is going to become 1/8. And vertically up, if the pattern were to repeat, it is going to be at a point that is here. So it is going to be something that is like this. Okay, and the coordinate of this point here is going to be at 1/4, 1. So it will cut at another point. So it will be 2 points already. Okay. So what you need to do is to just continue to go back. That means the next point you're going to be analyzing will be 1/16 and then 1/32. And if I were to just try to write down in the form of a table, this is what you will be expecting to see, okay? You'll be expecting something that is like this. If x is between half and 1, if x is between half and 1, if I were to analyze the number of solution, if I were to be analyzing the number of solution for gx is equal to x, the number of solution will be 0, correct? But if it were to be between 1/4 and, sorry, bigger or equal to, if it were to be between 1/4 and 1, 1/4 and 1, then I'll start to get one solution. If it were to be between 1/8 and 1, there will be 2 solutions. And of course, I can see this 1/4 using this as the inspiration. I can see this as 1/2 to the power of 2. I can see this as 1/2 to the power of 3. So what you are supposed to do is to try, although, I mean, one way is definitely to just keep drawing and drawing and then observe the number of solutions, but it's very difficult to draw because your graph will become so tiny. What you can try to do is to just continue and imagine, what if I were to have 1/2 to the power of 4, 1/2 to the power of 5, and if you to just keep continuing, when you go to 1/2 to the power of 9, x and 1, 1/2 to the power of 9, then after that 1/2 to the power of 10 and 1. These two numbers, if you were to press this into the calculator, 1/2 to the power of 9 is 0.00195531. 1/2 to the power of 10 is 0.00097656. You know why I'm interested in these two numbers? Because 0.001 lies between these two values. So this in between here is where 0.001 lies. And if I were to see the pattern of the number of intersection, which gives us the number of solution to this equation, if it is 1/2 to the power of 2, I have one solution. To the power of 3, I have two solutions, which means that to the power of 9, I'm expecting 8 solutions. To the power of 10, I'm expecting 9 solutions. Okay? So, which means that if it ends here, if we are talking about from here all the way until 1, we should be expecting 8 solutions, correct? We should be expecting 8 solutions. But if you think about it, you need to do a check. Let me explain to you what is the check. Because if you think about it, it really depends on where exactly is this 0.01. If I were to try to sketch for you the graph, that means I'm going to try to sketch this line for you between 1/2 to the power of 9 and 1/2 to the power of 10. I need to try to imagine, okay? So if I were to sketch the graph that is between 1/2 to the power of 10, 1/2 to the power of 9, I'll be expecting a graph that is going to be something that is like this. This will be at 1/2 to the power of 10. Let me exaggerate. So this will be 1/2 to the power of 9. So I will be expecting a hollow dot at 1/2 to the power of 9 and 1. And this line, y is equal to x. Because I'm exaggerating, okay? So y is equal to x is supposed to be cutting it somewhere. So this is y is equal to x. Okay, right? You will be cutting, right? Because the graph will just get steeper and steeper and steeper, so you will cut. So my interest now is where exactly it cuts, because I need to know whether it cuts before or after 0.001. So I'm going to do a check. Let me write it down here, okay? I want to find the intersection. And to find the intersection, we need the equation of this line. And the equation of this line can be derived from here, where n is equal to 10. So I am going to be letting 2 to the power of 10 x minus 1. I'll be letting this, which is representing this line, 2 to the power of 10 x minus 1 will be equal to this line, be equal to x. So 2 to the power of 10 x minus 1, minus x, this is equal to 1, and x will be 1 over 2 to the power of 10 minus 1, and this is equal to 0.000978. So I know that this number here is 0.0009, goodness, I don't have space, so 978, and it is before 0.001, which means that this intersection, which is the additional one here, is not going to be affecting when we talk about between a range that is between 0.001 to 1. That is why for this, my solution, the number of solution, my answer should be 8. Okay. This is essential, okay? This is necessary for you to check. It is not just dependent on 8. If you were to see that this is a 2 marks question and you're wondering, is he going a bit too in-depth, into doing all the checks? If you were to look at ACJC's solution, I don't have it with me now, okay, but if you were to look at ACJC's solution, I think they also actually did this check. No, I'm very sure they also did this check. And that is why it is not just that the question is difficult, but I'm questioning about the amount of analysis and solution that you're supposed to produce for the question. Like last week we did question number 7, and there was one integration by parts question, which ACJC gave just 1 mark, which I was also very surprised. An integration by parts question where you are doing a full integration by parts from scratch, and you are going to be awarded just 1 mark. Okay. I'm going to wait for a while to see whether any of you ask question. I'm surprised that none of you has asked questions so far. Wow, okay. There's really no question. Okay, I'm going to continue, okay? I'm going to continue with another question that again will have this huge question mark, which is question number 10. The graph that I sketched for x is equal to 1 over 8 is the 4x minus 1 graph. The 4x minus 1 graph, is for n equal to 2. The 4x minus 1 graph, the 1 over 8 is not the 4x minus 1 graph. Oops, what is happening? The 4x minus 1 graph is this. This is the y is equal to 4x minus 1. So this is 2 to the power of 3x minus 1. So it is the graph of 8x minus 1. Okay. Actually, right, Claire, I somewhat agree with you, because I know of students who actually score full marks, like 100 over 100 for the prelim, but because the examiner just doesn't want someone to score full marks, so somehow the examiner managed to find half a mark to minus off from that student. Well, let me very quickly just talk about the check again, okay? Okay, because we know that this line here, this line y is equal to x, is going to be cutting all this. I'm going to discuss about this check, okay? I'm going to hide this question first because it's like really blocking my face. So let me just very quickly explain about this check. Where I cannot guarantee that you will definitely get it. Okay, so what I need you to do is, after my explanation, try to think about it a little bit if you really want to get to know this question. So, so I know it is going to be cutting, every lines that I'm drawing this way. Cut, the the line y is equal to x will be cutting and cutting, and then the next line that I'm going to draw, it will cut again. So when I go all the way until the very last line that I am looking at, which is between 1 over 2 to the power 10 and 1 over 2 to the power of 9, it is still going to make an intersection. Okay, the line y is equal to x is still going to be making an intersection with this line here, it is very similar to this kind of line. Okay, so it is going to be intersecting. So I need to know where exactly intersect, because this intersection here is the ninth solution. So I need to know whether 0.001 is before or after this, because we are talking about x to be between 0.001 to 1. So we are talking about from wherever 0.001 is, all the way until x is equal to 1. So if 0.001 happens here, that means this ninth solution is going to be included in our answer. But if 0.001 happens here, because we are talking about from 0.001 to 1, then the ninth solution is not going to be included. So in order for us to do this check, we need to know exactly where this intersection took place. So looking at this graph, which is 2 to the power of 10, x minus 1, where I try to solve for the intersection with the line y is equal to x. And solving for the intersection, I realize that the x coordinate of the intersection is this number. So here, the x coordinate is 0.000978, which is less than 0.001. So I know the ninth solution happens outside 0.001 and 1, because the ninth solution happens before 0.001. And that is why the number of solutions that I'm looking at is 8. Okay, and now it's 909, and we have 3 more questions. I'm really not sure whether we will be able to finish. Okay. In fact, right, I don't think math is actually that difficult. I was telling some of you that I've been working on very difficult papers for the last 3 weeks in my tuition class, and I enjoy working on those kind of papers together with my students. I think that challenges the way we think and the way that we process H2 math, and really help us to truly understand the value of how H2 math adds to a better world. But this question here, right, I didn't really enjoy doing it that much, because I feel that it is pushing a bit beyond what I think is fair to be set during the exam. But that is my opinion. But the thing is, when I look at this question, I thought, okay, this question is like really okay. I mean, I cannot see the motivation behind this question. Okay, there must definitely be some reason why the question is being set this way. Until when I look at question number 10, and I realize question number 10 is also very, very much similar to this. We have a question that is very difficult to do during the exam. Question number 10, part 1. I think the second few parts are okay. But 10 part 1 took me a while to actually try to get how exactly I'm supposed to solve for A and D. Let me very quickly show you this 10 part 1. So 10 part 1, okay, why don't you guys take a look at the question first, okay? So for 10 part 1, we are looking at the intervals that is between the papers to be this. The criteria is written down here in these 5 sentences. And our aim is to try to stretch the period of the preparation to be as long as possible, so that so that the last paper is done as close as possible to the examination date, which is on the 91st day. What I'm going to try do for part 1, which I find again it is too difficult, okay? Not too difficult, but it is just too much to ask for a 3 hours paper. So anyway, part 1, I want to write down 2 inequalities. The first one is I'm going to focus on the total amount of time spent on the preparation, the total number of days spent on the preparation. So the total number of days, I will be adding A, then A minus D, then A minus 2D, which I can see that it is a GP, correct? It is an AP, sorry. It is an AP. It is an AP with the first term as A, and the common difference is minus D. The number of terms, we are talking about 9 papers. So the number of terms is going to be the number of intervals between the 9 papers, which is 8. Okay, 4 papers, 3 intervals. 9 papers, 8 intervals. So it will be 8 divided by 2. Then 2 times of the first term, 7 minus 1 times the common difference, which is minus D. So I have this. This is equal to 8A minus 28D. And I know the total number of days must be less than or equal to 90, because according to the criteria, everything must be completed on the 90th day. So I'm going to let this 8A minus 28D be less than or equal to 90. We are going to be manipulating this a little bit in a while. Okay, let me continue with the second inequality, because we are trying to minus D, minus D, minus D. So it really depends on the value of D. But regardless of the value of D, the last day must be bigger or equal to 1. With the interval span for the very last one must be bigger or equal to 1. And the interval spent on the very last, the time spent on the very last interval between the 8th paper and the 9th paper, according to the AP again, that will be A plus the last one, 8 minus 1 times D. Where this is the last interval, the number of days spent in the last interval, times minus D, and this must be bigger or equal to 1. We cannot be equal to 0 because we are supposed to be doing just 1 paper per day. We cannot be negative. How can it be even negative? Okay, that's why it must be bigger or equal to 1. Okay, and we are looking at it this way because we are minusing D, minusing D, minusing D. So we don't want to minus until I get a negative number of days, correct? So we want to make sure that this is bigger or equal to 1. So I'm going to get an inequality A minus 7D is bigger or equal to 1. And the next thing that I'm going to do is not something that I can explain to you. It is something that is really through trial and error. That means you are really literally trying and thinking. And I think the boundary that we are trying to think for this question is just too broad to be set for an exam. But I'm still going to just show you how I think through to get this. It took me way more than this 4 marks, way more than what I think I should be spending if I were to be doing it as a 3-hour paper, okay? So just to let you know that what I'm writing here is not exactly how I have gone through the process of generating the solution. I spent more time thinking about it than what I'm going to be doing next. So I'm thinking, okay, I'm going to just randomly sub values of A and D in to check whether it satisfies this and dissatisfies this, and whether it is going to give me the largest possible day. But whether it's going to give me the largest stretch of time so that the last paper is done as close as possible to the 91st day. So in order for this to happen, A must be as big as possible so that I can stretch the whole thing as wide as possible. But D must be as small as possible, because by making A as big as possible and by making D as small as possible, I can make each interval to be as wide as possible. Okay, this will spread out the papers as much as possible for the 90 days. So I'm going to almost randomly substitute values of A and D in. A must be as big as possible, D must be as small as possible. So I think one easier number to, between A and D, the number that is easier for me to start subbing in should be D, because I'm going to start D as 1, 2, 3, and so on, because D cannot be equal to 0. Okay, so minus D, minus D, minus D. I mean, D can be 0. Can D be 0? Maybe D can be 0, but D cannot be negative. Because it should do by decreasing the number of days by D. So I'm going to go for D to be 0, D to be 1, D to be 2, and then I'll see what is the corresponding A. So to do that, I have devised a way to look at A by making A here the subject. I will have this as 45 over 4 plus 7 over 2D. And by making A the subject, A is going to be bigger or equal to 1 plus 7D. And I'm going to do substitution by making D as the number that I'm going to be substituting. Let me draw a table and show you what I substitute, okay? I let D be equal to 0, let D be equal to 1, 2, and so on. And I am, let me show you what I did on my calculator. This is question number 10. So on my calculator, I did this. What I did was, I plant this expression into y1. I plant this expression into y1. And I plant this expression into y2. Because if I were to combine these two expressions together, this tells me that A must be bigger or equal to 1 plus 7D, and this must be less than or equal to 45 over 4 plus 7 over 2D. So for whatever D that I'm using, I know A has to be between this range. So I put this into y1, I put this into y2, and I generated for myself a table. Let me show you what I've gotten. Okay, so I've gotten this, and I can now see, okay, let me just write down for you. When D is equal to 1, when D is equal to 1, A is going to be between y1 and y2, correct? So A is going to be between 8 and this 14.75, and I'm working on and I want the largest possible A. So if I were to let the largest possible A be equal to, if A is between 8 and 14.75, if I were to let the largest possible A be 14, and what I'm going to do next is I'm going to find the total. So the total number of days, if D is equal to 1 and A is equal to 14, substitute into here 8 times 14 minus 28 times 1. This gives me the number of days to be equal to 84. Okay, let me just very quickly write down here, okay? So this is when I go for 8 times A, which is 14, minus 28 times D, which is 1. Okay? Then when D is equal to 2, I get from my calculator again, I can see that A is going to be bigger or equal to 15. It is going to be less than or equal to 18.25. So I'm going to go for A to be equal to, for example, 18. And when I go for A to be equal to 18, I'll get the total to be equal to 88, which is still fine because the total must be less than or equal to 90. But when D goes to 3, then I'll realize that A is supposed to be between 22 and 21.75, and this is not a number. You know, how can A be bigger than 22 and less than 21.75 at the same time? So this is out. So I can see that for the D that I'm experimenting with, this is going to be the closest possible to the 90 days. That is why for my answer, right, therefore I know D has to be equal to 2 and A has to be equal to 18. Okay, and I have no better way to try to explain to you this, because even when I was trying to do this, I did a lot of trial and error, like really literally a lot of trial and error. And the the x in the calculator here, with the x that is in the calculator here, somebody is asking, the x in the calculator here represents d. Sorry, d, this d. Okay, so I'm letting this d be 0, 1, 2, 3, and so on. I'm assuming you are talking about purchasing the live stream, right? So for us, we will be adding the live stream. So once you purchase, you can watch all the live stream. Even those that are after, as long as we publish there, you will be able to watch. And my suggestion, right, is actually not for you to just use prelim papers until your prelim. My suggestion is for you to use prelim papers all the way until the A levels. Because if you can actually squeeze out some time after your prelim, I would suggest that on top of the TYS that you are doing, you do prelim papers also. Because they train you on different things, and you need to be stretched. You need to continue to stretch yourself using prelim papers while you practice and get familiarized with the style of the A levels. But you don't try to practice an A level for an A level when you are actually working on a bell curve. You know, if there were to be one or two, I mean, if there were to be some other people who stretch themselves by working on papers that are more difficult, and if you were to continue to just work on the TYS, very likely you will regret. But that's what some students told me, who insisted that, hey, after the prelim, they're going to just work on the TYS, and then on the day they realize they are just not competent enough. Oh, okay. This is something that I've forgotten to mention. Okay. Good. You did this. Okay. This decimal. The reason why I press decimal here, I press on our Texas Instrument calculator. I press math and I select decimal so that y2 can be in decimal, where it is easier for me to analyze. On your calculator, if you were to press mode, if you scroll down, you will see that your solution should be by default auto. When it is auto, that means if you have pressed everything as fraction, it will automatically try to give you fraction as much as possible. So if you didn't put in this decimal, very likely your y2 will be in fraction, and then that makes it very difficult to decide that a is equal to 18. But what if like a is like 101 over 21? How do you know it is equal to 18? So it is easier to see when it is in decimal. So I try to convert and force this into decimal. There are two ways for me to force this into decimal. I either press this, or I can start by pressing it as 45 divided by 4 plus 7 divided by 2, then times x. With this, will also force everything into decimal, because division is going to be decimal, and the mode of your solution is auto, so it will automatically go to decimal. Okay, we are really running out of time. And the last two questions are actually they are not that difficult, but they are very tedious. Just in case I didn't manage to finish this, then let me consider whether we are going to continue again on another day, okay? Because the last two questions are also very, very good practice. But let me continue with the with part 2 and part 3. Part 2 and part 3, I find that they are way better questions. They are difficult, but they are definitely better than this 10 part 1 and question number 9 part 3. Yeah, I don't think I will be able to finish. In fact, my plan is not even finishing it by 10, my plan is to finish it by 9:30. So today when I was trying to look at this, I already, in a way, I gave up. If I were to just do without explaining, I think I can definitely finish by 9:30. But how can I not explain 9 part 3 and 10 part 1? And that's what I was looking forward to, it's a pain, but I was just wondering, how is it possible for me to explain something that is a little bit more abstract from my perspective. So anyway, oops, yep, my face is blocked. Hang on, let me remove this. Okay, I was just answering you this. Okay, I've given up. You know, I've given up on 9:30, and in fact, I think I'm also going to give up by that I can finish by 10. So probably I'll just, when you reach 10, if I really cannot finish, I'll probably just leave whatever question to either the next time, or maybe we should just skip this ACJC paper. Okay, now my face is unblocked. Let me take a look at part 2. What is the significance of this 92? I'm going to just talk about it, okay? This 92 is probably going to represent the highest possible marks that can be attained by the practice paper, the maximum possible mark. I'm really not sure, you know, like, is there anyone who actually want to do this all the way until midnight? I'm totally not sure. So anyway, so 92 is the highest possible mark. This is part 2. Let's take a look at part 3. Part 3 is sort of like interesting, good question. Part 3 is a good question. Part 3, if M is the average, we are supposed to calculate M. Okay, the average, which is M. So what is the average? We are looking at a total of 9 practice paper, and for each paper, the formula is this to get the marks. So we are talking about the average of 9 papers. So we are talking about U1 plus U2 plus U3 all the way until U9 divided by 9, correct? And we can, I mean, it depends on you. One way is to try to list down U1, U2 all the way until U9. It will work, okay? But I'm going to try to rewrite it into a summation notation. Okay, not necessary, because listing down according to this, it will also work. Okay, so there are different strategies. What I'm going to do is I'm going to list them down based on, I mean, by using the summation notation. So this is going to be 1 over 9. Then sum from R is equal to 1 all the way until 9 of UR. That is 92 minus 65B to the power of R. So we are trying to sum this, which is 1 over 9. Then summation of R starting from 1 all the way until 9 of the constant 92 minus 65. Then sum from R is equal to 1 all the way until 9 of B to the power of R, where B is a constant that is between 0 to 1. So I have a 1 over 9. Sum of a constant is going to be the number of terms multiplied by the constant. Number of terms is 9 minus 1 plus 1. So it's going to be 9 times of 92. Minus away 65. What we have here is a GP. In case you couldn't see there is a GP, this is B to the power of 1, then B to the power of 2, B to the power of 3, all the way until B to the power of 9. So it's a GP with the first term as B, the common ratio is B, the number of terms is 9. So 1 over 9 multiplied in, I have a 92, minus 65 over 9. Sum of a GP formula, B, 1 minus B to the power of 9, common ratio to the power of 9, common ratio to the power of number of terms, then divided by 1 minus B. So, okay, I think I can leave this as my final answer. This is going to be 65B, 1 minus B to the power of 9 divided by 9 times of 1 minus B. Given that he scored higher than M from his 4th paper onwards, so he's going to be scoring more than this. This is M. Okay, from the 4th paper onwards, which means that for part 4, U4 is supposed to be bigger than M. Okay, that's what the question says. U4 is supposed to be bigger than M. U4 is 92 minus 65, then B to the power of 4. This is supposed to be bigger than 92 minus 65B, 1 minus B to the power of 9, divided by 9 times of 1 minus B. So the 92 can disappear. B and B, I'm going to just cancel, okay? This B, I'll cancel this. I'm going to get a power 3. The reason why we can divide by B is because B is a positive number. B is between 0 to 1. 65, I think I'm going to also divide it away. So I will have a minus B to the power of 3. This is going to be bigger than minus. This minus I'm going to just bring in. So it's going to be bigger than B to the power of 9 minus 1. divided by 9 times of 1 minus b. Multiplying this across, I have a minus 9b to the power of 3 plus 9b to the power of 4. This is bigger than b to the power of 9 minus 1, which means that b to the power of 9 plus b to the power of 9 minus 9b to the power of 4 plus 9b to the power of 3 minus 1. This is supposed to be less than 0. And we are supposed to solve for the range of values for b. And I'm going to solve for this by pressing this into the calculator. I'm going to press the left hand side into the y1 of my calculator. I will draw the graph. Let me show you what I have on my calculator. Okay, I will press this into my calculator for the left hand side. Then my graph is going to be this weird graph, which once again, most likely during the exam, this graph alone, solving this equation alone is going to slow us down. That's why I really feel that this paper is very difficult for a typical student to finish within the 3 hours. For an exam that is held on the 29th, right? This paper was held on the 29th of August, which is an early prelim paper. So the student could have gotten even more preparation if it were to be held after the September holiday, which some schools are doing that, but this was held as one of the earliest paper. So anyway, from my graph, I see this. By the way, this part is very close to the x-axis, but it is actually like above the x-axis like this way. So I will find this value. This value is this. So I know x is supposed to be, b. So I know b is, for this to be negative, b is supposed to be less than 0.726 to 3 decimal places. But because b is supposed to be bigger than 0 to 1, that's why I'm going to add in extra bigger than 0. So b is between this and this. Okay, let me do the next question. The next question is a differential equation question. Hang on, let me erase this. So let's take a look at question number 11, and maybe we will have a chance to look at the last question, which is a vectors question. So now question number 11. Question number 11 is okay. The problem is it is just going to be pretty tedious, and the previous few questions, they have probably already taken up a lot of time from a student. So well, I don't think 11 is easy to be done during the exam still. We have this differential equation. Yeah, actually this is a good consideration. We should also try to consider whether U5, U6 and so on, they are bigger than M. But I feel that the question could have made it clearer. But I guess the reason, I guess one hint that they are trying to give, which is very, very subtle, is the marks that is allocated. So if you are going to check U4, if you are supposed to go and check U5, U6 and so on, I seriously don't think there will be enough time for you to finish this. So you can give it a try, where you will end up with the same, you should be ending up with the same answer. Okay, so, but this is a very good consideration, okay, because I was also thinking, when I was looking at the question, I was also thinking, like, shouldn't we check more scores, instead of just U4, because we need to make sure that U5, U6, U7, all the way to U9, they are all going to be bigger than M. How do you know it is going to be so, right? So but at the same time, because okay, hang on. At the same time, because R is a positive number, the common ratio B is between 0 to 1. So it is, so this is an increasing GP. Yeah, so this should be an increasing GP, and because this is an increasing GP, if U4 is already bigger than M, the limit is in U4. Because it is impossible for U5 onwards to be less than M. That's why I think checking U4 is enough. Wait, I'm so sorry. I keep seeing this. Never mind. We can do till midnight. Can I just archive this? So, okay. Anyway, we are given that v is equal to dx dt. I want to write down a differential equation in terms of v and t when I'm given this. So if v is equal to dx dt, that means dv dt is going to be d square x dt square. So for this equation that we are given here, d square x dt square plus k times of dx dt square. This will be dv dt plus k times of v square. This is equal to 10. 1 mark. And we are given that dv dt is 6 when v is equal to square root of 10. V is square root of 10. Then dv dt, this is equal to 6. So substituting this in should be able to help us to solve for k. It will be dv dt, this is 6, plus k times of square root of 10 square. So k times of 10, this is equal to 10. So this will help us to solve for k. K is going to be equal to 2 over 5. So now we have dv dt plus 2 over 5 of v square. This is equal to 10. And we are given that the initial velocity of the toy is 0. So this piece of information here is telling me that when t is equal to 0, v is equal to 0, which we will probably be making use of to solve for an arbitrary constant later once we have gotten an equation between v and t. So to get the equation for v and t, we are going to try to solve this differential equation. It is a variable separable kind of differential equation. So what I'm going to do is I am going to try to bring the v across to the other side to multiply by dv dt. So to do that, I will do this over 5v squared, which I can rewrite it as 50 minus 2v squared over 5. Or maybe we can even write it as 2 over 5 of 25 minus v squared. I think this will make it even easier to integrate. So I'm going to divide this 25 minus v squared over to the other side, which will give me a 1 over 25 minus v squared of dv dt. This is equal to 2 over 5. And integrating both left and right hand side with respect to t, this will be 1 over 25. I'm going to write it as 5 squared minus v squared dv. This is 2 over 5 integration of 1 dt. So integrating this using what I have in my formula sheet, MF26, it is 1 over 2 times of this 5. Then ln modulus of 5 plus v divided by 5 minus v. This is 25t plus an arbitrary constant. I'm going to go for a. So ln of modulus of 5 plus v over 5 minus v. Multiplying 10 across to the other side, this gives me a 4t plus 10a. Removing the ln on the left hand side, modulus of this over 5 minus v. This will be e to the power of this, which I'm going to rewrite it as e to the power of 10a, e to the power of 4t. Let me continue here. Removing the modulus, this gives me a 5 plus v over 5 minus v. This is equal to plus or minus e to the power of 10a, e to the power of 4t, which I am going to just rewrite it as be to the power of 4t. So this b here is plus or minus e to the power of 10a. I think we can make use of this now, or if you want to make v the subject like this, then making use of this, it is also fine. But I think I'm going to go for it like right now. So when t is equal to 0, I know v is equal to 0. Substituting it into this, I will have a 5 plus 0 over 5 minus 0 is b e to the power of 0. This tells me that b is equal to 1. Therefore, I know 5 plus v over 5 minus v. This is going to be 1 e to the power of 4t. Let me continue here. So I'm continuing like on top, okay? So I have I'm going to cross multiply, but if you were to look at what you are supposed to show, you need a 4 e to the power of negative 4t. Okay, this is e to the power of negative 4t. Yes, you can rewatch it on the, if you were to scroll down on the Achevas, on the online.achievers.com/live. If you're on that page, if you were to scroll down, you will see a playback button. You can be rewatched on the playback button. I mean, if you can be rewatched on that page. But it will take us a while for us to publish this video, so it's not going to be immediately after this. So anyway, I'm going to divide this across so that I can get a e to the power of minus 4t. Okay, so I will have a 5 plus v, then e to the power of minus 4t. This is equal to 5 minus v. So multiplying in 5 e to the power of minus 4t plus v e to the power of minus 4t. This is 5 minus v, and I'm going to put all the v onto one side, and I'll factorize out the v. This will be, bringing this v over, I'll have a 1 plus e to the power of minus 4t. Bring this over and factorizing out 5, I have a 1 minus e to the power of minus 4t. So v here is 5, 1 minus e to the power of minus 4t divided by 1 plus e to the power of minus 4t. Okay, and this is what the question wants us to show. The next part is easy. In the long run, we are talking about t tending to infinity. So when t tends to infinity, v is going to tend to 5 times of 1 minus 0 divided by 1 plus 0, which means that v, the velocity, is going to tend to 5 meters per second. Okay, I guess this is not too bad. And the toy is going to be released from a height of 10, and we are supposed to find the time when the toy reaches the ground. Okay, this is another long part of question number 11. If you were to look at the question, x is going to be defined from the point where the toy is being released. So if the toy is being released here, then after a while, if the toy is, let's say, here, this is going to be equal to x, which means that when it is going to be released, this is going to be equal to x, which means that in the beginning, when t is equal to 0, x is supposed to be equal to 0. And what the question wants us to find is when the toy reaches the ground, which means that the toy should have traveled the full distance, which is 10 meters. So when x is equal to 10, okay, the question is asking when x is equal to 10, find t. So we need an equation that is relating, that is in terms of x and t. And to do that, we are going to do another round of differential equation. Because now we have gotten from the previous part that v is equal to that expression, and v is dx dt. So let me just rewrite it here. V, which is dx dt, that is given to us here, is equal to this, which is 5 1 minus e to the power of minus 4t divided by 1 plus e to the power of minus 4t. So for this over here, this is a simple differential equation. So for this simple differential equation, to solve it, it is just simply integrating the right hand side because it is just in terms of t. So this is going to be integration of 5, 1 minus e to the power of minus 4t divided by 1 plus e to the power of minus 4t dt. I personally don't think this is a very difficult integration. I mean, this is not a very difficult integral, but it really depends on your preparation. Okay, if some of you are already pretty prepared in terms of integration technique, you will probably have done something that is similar to this. Then this question will be okay. But if you are not that prepared, then whatever that you're going to see next may intimidate you a little bit, but it is fine. Okay, and there are different ways to solve this, so you don't need to use the one that I'm showing you here. What I'm going to do here is I'm going to split this into two parts. 1 over 1 plus e to the power of minus 4t dt. Okay, 1 divided by this. So 5. Okay, so 1 divided by this, then plus integration of the other one, which is minus e to the power of minus 4t divided by 1 plus e to the power of minus 4t dt. For this, I'm going to multiply the numerator and the denominator by e to the power of 4t. Then this will be e to the power of 4t plus 1 dt. For this, I'm going to keep it as it is, but I'm going to introduce a 4 to the front. So I divide by 4 so that I can have a minus 1 over 4. So I can have a minus 4 e to the power of minus 4t, 1 over 1 plus e to the power of minus 4t dt. Because if I were to treat this as fx, then this is going to be my f prime x. And I'm going to do likewise for this. So let me rewrite this. Well, let me just rewrite it here, okay? So I will have a 1 over 4 outside. Okay, I will just do the whole thing. So it is going to be equal to 5. Then 1 over 4. Then I'll have a 4 e to the power of 4t. This is my f prime x. And fx is e to the power of 4t plus 1. This entire thing is my fx. This is my f prime x. So 1 over 4 minus 4e to the power of minus 4t, 1 over 1 plus e to the power of minus 4t dt. So this is 5. Now let's take out 1/4. So integrating this, it is ln modulus of this, which is always positive. So I'm going to just use a curved bracket. Then plus ln. Again, this is always positive, so I'm going to just use a normal bracket. Then plus c. And like what we have just deduced, when x is equal to 0, t is equal to 0. So I know that 5 over 4 ln e to the power of 0 is 1 plus 1 plus ln 1 plus 1 again plus c, this is equal to 0. This will get me a c that is 5 over 2, or minus 5 over 2. Minus 5 over 2 ln 2. Okay, so now we have gotten, now we would have gotten x. And this x is equal to 5 over 4 ln e to the power of 4t plus 1 plus ln 1 plus e to the power of this plus c, which is minus 5 over 2 ln 2. And we are supposed to let x be equal to 10 and solve for t. And again, it is way more tedious than what I think a typical paper should be set. So when the toy touches the ground, that is when x is equal to 10. So when x is equal to 10, 5 over 4 ln e to the power of 4t plus 1 plus ln 1 plus e to the power of minus 4t minus 5 over 2 ln 2, this is equal to 10. And I'm going to press this into the calculator to solve for t. Let me just very quickly show you what I've gotten on my calculator. If I were to draw the two graphs, I'm going to get this value as t. So it is going to be this. The blue color one is the left hand side. Obviously, this one is the line y is equal to 10. So from GC, I can find t. T is going to be equal to 2.35 seconds. Actually, I think it is not that bad. Maybe I should just finish up the vectors question, the last question. Let me just finish up the last question, okay? Especially I think JC students usually sleeps later. I'm not sure. I can't really remember what time I sleep when I was in JC, but I totally remember what time I sleep when I was in the university. You know, I think my average sleeping time when I was in a university, a lot of people were very shocked. They were really very shocked. The average sleeping time should be around like 10 plus to 11 when I was in the university. Because so many people, they will be studying overnight. And they will be sleeping at like 2, 3, especially those people who stay in the hall, they are basically not sleeping at all. But I usually sleep like between 10 to 11. Then people are like asking me, how are you able to finish your work? Even when there's exam, I also sleep before 12. So a lot of people were very surprised. JC don't sleep, are you sure? You know, if you don't sleep, you're going to die. So if you are taking, I think it will just take a few days, right? I'm not very sure. Is it 7 days or something? And then the organ is going to just crash. Then after that, slowly the person will die. So for hello, oh crazy, for hello. Okay, if you plan not to sleep, right? You must plan, okay, so that you can at least last through your A levels first. Okay, let me very quickly finish this 12. Okay, 12 is actually not that bad. I think I can probably skip some parts which are very easy so that we can do it a little bit faster. So okay, F1, the line that the aircraft F1 is flying, the path that it is flying is this. So I'm going to call this LF1, and this is R is equal to 1, 2, 3 plus lambda of 2 minus 4, 1. Okay, as for this, I'm going to leave it to you to do the conversion. Okay, it's not very difficult. I'm going to convert into the vector form, LF2. Into the vector form, this is R is equal to R is equal to, this is minus 2, 1, 3. Then plus, let's say, mu of 1m and minus 7. Okay, so I have LF1 that represent the path that the aircraft F1 is flying, and this represents the path that F2 is flying. What can you say about M if the two aircraft they are not going to be intersecting? The two aircraft, the path of the two aircraft are not intersecting. So what I'm going to do is, what if they intersect? So if they were to intersect, I'm doing part 1. I'm going to let this be equal to this if they were to intersect, which means that I will be working on 1 plus 2 lambda, then 2 minus 4 lambda, and 3 plus lambda. I'll let this be equal to this, which is minus 2 plus mu, then 1 plus m mu, then 3 minus 7 mu. From the first row, I will get a 1 plus 2 lambda is minus 2 plus mu, which gives me a 2 lambda minus mu is equal to minus 3. This will form for me my first equation. Then for my second equation, from the second row, 2 minus 4 lambda is equal to 1 plus m mu. I'm going to make m the subject, okay? M is going to be 1 minus 4 lambda divided by mu. This will form for me my second equation. And for the third row, 3 plus lambda, this is equal to 3 minus 7 mu. This gives me my third equation. Lambda plus 7 mu is equal to 0. Then if I were to solve for equation number 1 and equation number 3 using my GC, I'll get lambda to be equal to, let's see, from my GC, lambda is going to be equal to minus 7 over 5, and mu is equal to 1 over 5, which means that m is going to be 1 minus 4 times of lambda, minus 7 over 5, divided by mu, which is 1 over 5. So m is supposed to be equal to 33. That is if they were to intersect, which means that if the two paths are not intersecting, m cannot be equal to 33. Okay? So if they were to be intersecting, m is 33. If they are not intersecting, m cannot be equal to 33. Part 1. Next, part 2. Part 2, we are looking at a controller who is which is 3 units above the base. The base is at 0, 0, 0. So we are talking about something that is like this. With the controller, the base is at 0, 0, 0. 3 units above the base, maybe somewhere here. I'm going to call the controller C, okay? So C should be 0, 0, 3. 3 units above. And F1 is flying past this controller. So let's say something that is like this. So this path is going to be LF1. The signal is going to be the strongest when this aircraft F1 is the closest possible to the controller, which means that it is going to be the strongest when the aircraft is here. What is this distance when the signal is the strongest? So we are supposed to find this distance, and to find this distance, we are going to use geometry. And if you are from my tuition class, we call this geometry our right-angled triangle, which we call it the magic triangle that we are using. So we are going to be making use of the magic triangle, okay? What we are going to do is we're going to find a point that is going to be on LF1, and I guess this is one good point. I'm going to call this point let's say A. So A, I'll go for 1, 2, 3. And if I were to join A to C, then I will have a vector AC, and this distance here, we are talking about it as modulus of AC. And if I were to assign angle theta to this, because I know that this line is parallel to 2 minus 4, 1. It is parallel to this. So I'm intentionally assigning angle theta to be here, and then applying Torcaso. I know this distance here is modulus of AC sine theta. And because of the place that I've assigned theta, instead of this, I'm assigning theta to here, which is the angle that is between two known vectors. And since I see a sine, I can now make use of the cross product. So if I will take AC cross 2 minus 4, 1. Applying, this is just the formula for cross product. It is modulus of AC, modulus of 2 minus 4, 1, and sine of this angle, where we have chosen it properly to be the angle that is between the two vectors that is in my cross product. So from this equation, I can work out another version for modulus of AC sine theta, which was derived from Torcaso. So this sine theta, this is modulus of AC cross 2 minus 4, 1. This divided by modulus of 2 minus 4, 1. Okay, so I guess what we are going to try do is let's try to find AC first. AC is going to be OC minus OA. OC is this 0, 0, 3 minus away OA, which is 1, 2, 3. This gives me a -1, -2, 0. So the shortest possible distance is going to be modulus of AC cross 2 minus 4, 1. This divided by modulus of 2 minus 4, 1. So AC here is this -1, -2, 0. Cross 2 minus 4, 1 divided by modulus of 2 minus 4, 1. And it's not like you guys cannot do cross product, okay? So I'm going to just assume that you know how to do the cross product and you have done everything correctly. Your answer here, the answer here is square root of 23 over 7. Okay, this is part 2. Next, let's take a look at part 3. And in part 3, we are looking at m to be equal to 5. So let me change this, okay? M is supposed to be equal to 5. So we are looking at this as 1, 5, and -7. Okay, so we are having a new m here, which is replaced by 5. And this is a question that talks about reflection. If I were to sketch according to what the question says, we have we are talking about this line LF2 being reflected about the line LF3. And for LF3, it is given to us as a line that passes through the point 1, 1, 0. I'm going to go for alpha. And it is parallel to 1, 0, minus 1. And the reflected line is LF4. So we have this LF4. Part 3. We are supposed to find the plane that contains all the three paths. So I mean, this is simple. It is just the plane that contains the three paths is the same as the plane that contains just LF2 and LF3. LF2 is parallel to the vector 1, 5, minus 7. LF3 is parallel to the vector 1, 0, minus 1. So the normal vector to that plane is going to, the plane is going to contain these two, the plane is going to be parallel to these two vectors. So the normal vector can be obtained by taking 1, 5, minus 7 cross 1, 0, minus 1. And this gives me a -5, -6, -5, which later I'm going to use a 5, 6, 5 instead. So I'm factorizing out the -1. So the equation of the plane, I guess that's why the question chose to use the word aircraft. So this is r dot 5, 6, 5 is equal to, I'm going to take the position vector of a point. Let's go for this point. 1, 1, 0 dot 5, 6, 5. And this is 5 plus 6. This is 11. So the Cartesian equation is 5x plus 6y plus 5z. This is equal to 11. And part 4. Part 4, we are supposed to find the equation of this line LF4. In the theory outline on the Achevas TV, on the very last page of the vectors outline, there is a process. There's a process that can help you to find reflection of almost all the geometries that is in your vectors syllabus. For those of you who are able to access the videos, please take a look at what I discussed within the videos, because in the videos, we just simply discuss about how we can get a reflected point from a point, a reflected line from a line, a reflected plane from a plane, and all the other cases. Because all these can be studied before your exam, and you should definitely try to do that. You don't have to wait till the exam, and then on the spot you try to work on reflection. It should be a prepared kind of you can actually prepare for it. So in general, on the outline, right, I highlighted two steps, which will usually takes place for all reflection question. Number one is you're supposed to get some points and then find the foot of perpendicular. We just find some point and work on some kind of foot of perpendicular. Then secondly, you will find the reflection of that point about the foot of the perpendicular. So what I'm going to do is, I'm going to follow these two steps. And so for the foot of the perpendicular wise, my decision is to pick a point that is on LF2. An obvious point that I can pick is this point, -2, 1, 3. And I'm going to call this point here, let's say B. For the foot of the perpendicular wise, I'm going to drop this down to find a foot of perpendicular, which I'm going to call this point N. So my plan is this. I'll find the foot of the perpendicular. Then after that, I'll reflect this about the line LF3 to find the reflection. Because the reflection, I'm going to call it B prime, will be lying on LF4. And if I can then find the intersection between LF2 and LF3, this point, then if I can find the coordinates or the position vector of this point, and now that I have this point, I will be able to find the equation of the line LF4. So this is the strategy. I discussed it in the video on the Achevas TV outline, theory outline. And these two steps are freely shown on the outline also. So let me proceed with this by first quoting the fact that N is a point that is on LF3, which means that ON is going to be equal to 1 plus alpha, 1 and minus alpha. Which means that for BN is going to be ON minus away OB. Okay, and if you were to work this out, ON minus OB is going to be equal to 3 plus alpha, 0, minus 3 minus alpha. And I know BN is going to be a line that is perpendicular to LF3, and LF3 is parallel to 1, 0, minus 1. That means BN dot 1, 0, minus 1, this is going to be equal to 0. So 3 plus alpha, 0, minus 3 minus alpha, dot 1, 0, minus 1, this is going to be equal to 0. If you to work out the value for alpha here is going to be equal to minus 3. And I'm going to substitute this back into here to find ON. So therefore, ON is going to be equal to 1 minus 3, 1 and minus 3. And this gives me a minus 2, 1, 3. An interesting point, you know why? Because minus 2, 1, 3 is exactly this point, B. That means N and B synchronize. You know what we have found? We have unintentionally found this point. You know, the intersection between LF2 and LF3. Because B and N happen to be exactly the same. Okay, so we got to react. Let's be flexible. So this point here, I'm going to now call it point N. And this N is minus 2, 1, 3, which is actually this point. So I'm going to redo this again because I still need one more point. So I'm going to call this something else, okay? Let me call this, let's say, D. And I'm going to call this, let's say, P. So we're going to find D prime. Okay, because we have accidentally, through the process of finding the reflected point, then we found the point of intersection. So I'm going to go through this process once more. That means OP is going to be this 1 plus alpha, 1 and minus alpha. As for OD, I can't possibly use this point anymore because this point is supposed to be here. So I need another point that is going to be on LF2. So to find another point that is on LF2, it just depends on mu. Mu can be any real number. So what if I were to let mu be equal to, 1, for example. So if I were to let mu be equal to 1, then it will be minus 2 plus 1. It will be minus 1. Then 1 plus 5, then I'll have a 6. Then 3 minus 7, I'll have a minus 4. So I'm working on another new point, minus 1, 6, minus 4, which is also on L2. So OD here, I'm going for a minus 1, 6 minus 4. So from this, I can find dp. Okay, I can find dp, and that will be op minus od. This will give you 2 plus alpha minus 5 and 4 minus alpha. And similarly, we know dp is going to be perpendicular to the line, which means that dp dot 1, 0 minus 1, this is going to be equal to 0. So 2 plus alpha minus 5, 4 minus alpha dot 1, 0 minus 1, this is going to be equal to 0. Working out the value of alpha here is going to be equal to 1. This will help us to find OP. OP will be 1 plus 1, 1 and minus 1. And since now I know OP, I can find the reflected point, number 2. To find this reflected point, I'm going to reference all this to the origin and apply the ratio theorem, because I know this distance, since it's reflected, is the same as this distance. That means the ratio is going to be 1:1, which means that if I were to refer all this to the origin, OP is going to be 1 time of OD plus 1 time of OD prime divided by 1 plus 1. This makes OD prime 2 times over 2OP minus away OD. OP is this, OD is this. So OD prime is going to be equal to 5 minus 4, 2. So now that I have OD prime, I will be able to find ND prime, which is OD prime minus away ON. ON is minus 2, 1, 3. OD prime is 5 minus 4, 2. This minus this gives me a 7. Gives me a 7 minus 5 minus 1. Finally, we have my answer. We have our answer for LF4. The last question, the last part, which is R is equal to, I'm going to go for a point. Let's go for just this point. So minus 2, 1, 3 plus beta of 7 minus 5 minus 1. Okay, we are done.